Sir, you can start, sir.
Yeah, thank you, Yogi. Good evening, everyone. It is my honor and privilege to introduce our distinguished speaker for today's session. Today's speaker is a strange personality. He is having many degrees in psychology, structures, philosophy, and he did PhD in structures as well. Let me introduce today's speaker, Dr. B. Santosh Kumar. Dr. Santosh completed his diploma in civil engineering in the year 1995. After that, he joined in AMIE, Institute of Engineers, and completed his AMIE in the year 2000. And after that, Dr. Santosh completed his master's in psychology from Dr. B.R. Ambedkar Open University, Hyderabad in the year 2009. And he also completed his master's from Jawaharlal Nehru Technological University, Anantapuram in the year 2012. And Dr. Santosh Dr. Santosh also did his Master of Arts in Philosophy in the year 2024. And moreover, Dr. Santosh completed his PhD from Geetham Deemed to be University, Visakhapatnam in the year 2000. Coming to his professional experience, Dr. Santosh served as Assistant Executive Engineer in Water Resources Department, Andhra Pradesh from 2004 to 2012. After that, he has been serving as Deputy Executive Engineer, Water Resources Department, Andhra Pradesh from 2012 to present. He is a person with driven and confident professional with a passion for continuous learning and research. He is an active member in so many professional bodies, namely Institution of Engineers, Indian Geotechnical Society, Indian Institute of Bridge Engineers. Dr. Santosh published textbook on remote sensing, and he is active researcher on the topics namely seismic design, transmission line, dynamic analysis, reinforced concrete, and seismology. Sir, with your brief introduction, we impressed with you, sir. Really, we are honored to have you in this faculty development. We sure to gain valuable perspectives and practical takeaways from your session. Thank you, sir. Thank you for being with us. Over to you, sir.
Thank you for the kind consideration of your valuable words about me. This is Dr. B. Santosh Kumar. My voice is audible? Please.
Yes, sir. Yes, sir.
Okay,
yes, sir.
okay. Thank you. This is B. Santosh Kumar. Yes, this is B. Santosh Kumar, working as the Deputy Executive Engineer Irrigation Department, and I am also alumni of the JNTU Anantapur. My PhD was done in the cyclonic factor in the analysis of the structures. Because of this, I was given this opportunity. Because of this opportunity, I have delivered my best of knowledge to the students or the faculty members or the other persons. I am presenting my Is my screen is visible, sir?
Sir, could you please share your screen?
Yes, my screen is 1 minute. I am sharing my screen.
Yeah, please, sir.
Is my screen is visible?
No, sir.
1 minute.
Sir, there is a tab in Google Meet present now.
Yes. Because since Sir JNT is presenting is there, but I am giving share now. This will allow you to take over from the Sir JNT
Yes,
as the main
yes,
presenter.
yes, sir.
Kindly give me the option.
No, you select yes, sir.
Entire screen.
Yeah, enter screen only, sir.
Okay. Entire screen.
Go to enter screen and select the window, sir.
Yes.
Then
Is
click
this
OK.
is this okay?
No, sir, you are not yet presented.
Wow. No. I am. Enter screen is there. Now kindly give me the.
Yogi, could you please
Give me the.
stop sharing your screen?
Sir, can share directly, sir.
No, but I am unable to share.
Sir, just
What is
1 minute. Just hit on the fifth button from left, sir. There is one
Yes, sir.
tab
1, 2,
present now.
3, 4. Yes, sir. Present is there. Entire screen. I am
Yeah.
home tab window or the entire screen.
Hit on enter screen.
Okay, 1 minute. This.
Yeah, it's working now.
Yes, thank you. Sorry for the late
Sir,
distance.
sir, please now just go to presentation mode, sir.
Okay.
Yeah, great, sir.
Okay.
Thank you very much.
Thank you. So my main topic and my design orientation is the prescription of the IS 875 Part 3 2015 code provisions. This code is because of IS 875 part has the 5 parts: 1, 2, 3, 4, 5. One is the dead load, second is the live load, third is the wind loads. Because of the wind load, even though this is the load carrying capacity of all Texas, this is the separate load consideration when compared to the dead load and live load. This has the many importance because of the low-rise building to tall buildings. This is the very importance for the steel structures. So that is the second slide is the effect of wind loads and design of the wind sensitive structures. The wind sensitive structures means there is the tall structures, B by D ratio, that is the H by B ratio less than or equal to 5, or the frequency of the structures is less than 1 hertz. So this is the wind. Actually, the wind has been determined or calculated with the anemometer. The left side, which is the left side, what it gives is this is the anemometer provided that the Indian Meteorological Department in the Visakhapatnam or Hyderabad, the Nagpur or Delhi. This is the height from the ground level to 10-meter heights. It has been provided. It gives the 3 cups. It giving the wind velocity. Second one is the anemometer, that is the direction of the wind. The both has been derived from this. This is known as the anemometer. At the same anemometer giving into the other side, which is the hourly wind velocity or the peaks. This is the horizontal wind equivalences. That is the single peaks, 1 second to 1 second, 2 seconds. All these, this is the known as the second one is the horizontal line is given in the peaks and variations with the single peaks and over the duration of the morning 8 to evening 8. This is the anemograph. Right side is the anemometer. Anemometer is the device for the measuring of the wind. This is the graph showing the anemometer or the wind graphs. This is the single peak. That the left side, what is the 6090? This is the what the IMD has given in the knots, not in the kmph. The third one, the fluctuating of the wind. That is what the second slide is giving. This is the fluctuating. The fluctuating is calculated or the converted into the statistics. This is like that. What is the time period from the 0 to 400 seconds? What is the time period? And that is the velocity. How it is the velocity is averaged. That average is the normal distribution curve. The right side is giving in the normal distribution curve. Left side is the anemometer graph converted into the this average wind velocity. What is the wind? First of all, we have to let the wind and the air. Air and the wind are the same, but air is the normal motion, wind is the motion of the wind, motion of the air. But the horizontal component, the wind has the three characteristics, X, Y, Z, the spatial with respect to time. But the horizontal component of the wind is taken as into consideration for the our structures, mainly civil engineering structures. The velocity is the left side is this is the boundary wall. This is the boundary layer. The boundary layer means the variations of the velocity of the wind. The wind velocity is changing from the zero to highest point, that is the gradient height. It is taken into the according to the turbulence of the wind velocity, according to topographic conditions, height of the structure, and other characteristics. It is known as the profile of the wind. The profile of the wind profile is taken into consideration of the power law. When compared to the others, this is the only power law. Power law means some x to the power of alpha or the y. It is taken in the with respect to the turbulence of the topographic factor. Recently, the power law has been changed into the logarithmic 10 log of e of some x. This is the recently changed into the picture. For assessing the wind loads, generally the wind is categorized into the two types. One is the non-rotating winds. Second one is the rotating winds. Non-rotating means these are the only stable non-cyclonic period. When in the January to December, only the cyclonic period is the July to September or October. These are the rotating winds. These are the pressure differences are the cyclonic winds. These non-rotating of the winds are the defined as the non area of the that is the non months of that is the July to excluding the July to September. Yes, the non-rotating by the differential pressure and moved in the preferred direction. Their intensity is measured by the Bureau of Fertility. This is the normally in the International Meteorological Department or the Indian Meteorological Department has made some scale. According to scale, the knots are the meters per second or the kilometers per second. This has been divided into the some portions. What is the kilometers per hour? In the Bureau of Fertility scale, from 0 to 12. What is the calm to hurricane? 117 kilometers per hour. The wind, because of light breeze, we are talking about the when you are in the winter season, it is the light breeze. It is the we are perceived into the 6 to 11 kmph. This is the wind felt on the faces. If it is a moderate to 50 to 61 kmph, inconvenience when walking, we are blowing away or we are instability. And in case of the 75 to 80 strong gales, people are blown away by the gales or gusts. And in case of the 89 to 102 kilometers, small trees are uprooted. And in case of the hurricanes, 117, we know in the cyclonic in the Andhra Pradesh has experienced the many of the cyclones, and this is the rotating winds. Rotating winds are the pressure difference, the low pressure. Because of the low pressure, that is the Bay of Bengal and the Arabian Seas, because of low pressures in the during the rainy seasons, low pressures has been formed due to the adiabatic and atmospheric pressure differences. These cyclones have been formed. Because of the cyclones have been formed, the IMD Indian Meteorological Department has been classified some of the depressions of the super cyclone storms. Because of the cyclonic gale winds are the very high when compared to the normal winds. That is why we have to introduce the some wind multiplication factor of the K4 cyclonic effect factor. This is the sustained wind speeds. The sustained wind speed is provided or the given the definition is the 3 minutes per second. But our the basic wind speed is defined as the 3 seconds. Up to what is the 3 seconds of average of wind speed, but the sustained wind speed is kilometers per hour is the 3 minutes of 3 minutes period of average period. This is the difference between the sustained wind speed of the cyclonic and the basic wind speed of our code definition. So generally the wind loads on the structures IS 875 part 3 2025, the design loads for the buildings, these are the only design loads. That is the minimum design loads when compared to the IS 875. Because of IS 875 is the many replications of the Australian code and some part of Euro code and some parts of the American codes. But most of the percentage of the codes are replications of the Australian code. Because why it is? Because because the Indian Ocean is we are on the south of the, we are on the north of the Indian Ocean, that is upper side of the Indian Ocean, and at the same time the Australian is in the south of the Indian Ocean. Many of the strong winds are similar to the our country and the Australian country and the New Zealand countries. That is why so many of the wind programs or the wind loads, wind designs or wind research has been carried out in collaboration with Australia and India. In the IS 875 part 2015, before 2015, 1964 is the first version, 1987 is the second revision, 2015 is the third revision. In this third revision also, two amendments, 2016 is one amendment, 2020 is the second amendment have been relieved. So for the design of the any structures, the broadly classified in the wind effects on the structures which is in the static analysis and the dynamic analysis. This static analysis means the rigid and stable structures. The dynamic analysis means the stall and the flexible structures. In the static analysis, we are in the pressure coefficients method, and second one is the force coefficients method. In the pressure coefficients method, there is the internal structures, that is the gable roofs or the gable roofs or the wind, that is the building or the cladding or the any fixtures of the roofs. That is the A-type process or lean type process have been designed with the pressure coefficient. This four coefficients is mainly taken into the what is this hoardings or any tall solid structures or the hoardings. Mainly the hoardings is considered into the force coefficients method or the other structures. Hello. So second one is the dynamic analysis. This is the dynamic analysis. This is the best factor method.
Yogi, could you please mute all the participants?
And then, sir, please continue.
Shall I continue?
Yes, sir. Yes, sir.
Oh, sorry. In the dynamic analysis, there is a gust factor method. That is the random response and the periodic response. The random response means without any periodicity, without any replication. In the random response of the window, the Indian standard has been provided in the gust factor method for the design of the tall and the flexible structures. So wind pressure on the structures, that is the static wind loads. Generally, the buildings which are more than the 10 meters height of the above the ground level up to the 20 meters, it is a low-rise building. 20 to 50 meters is the high-rise buildings. Up to the low-rise buildings, we are taking into consideration of the static wind loads. But it is the static wind loads, but it is the semi gust factor, because it is equivalent to static wind loads, because of the wind profile of the wind is the fluctuating compound, but the fluctuating compound is not too much impact on the structure, because of this is the rigid structure. The rigid structure means the natural time period is less than 1 second. That is why these are the static structures. The structures which are mainly the concrete structures are not relevant, but the steel structures are the industrial structures. Third one is the tall telecommunication towers or the electrical towers. These are the more prone to the wind loads. Because of the wind loads, this is the only VZ means the velocity of the wind at any height of Z. VB means is the basic wind speed of given in the definition, the K1, K2, K3, K4 of the wind speed multiplication factors. The pressure is defined into the 0.6 into Vz whole square. But that is the Vz whole square means Z to the power square, that the power of Z. That is why we are taking into the power law. In case of the logarithmic law, the 0.6 into some log of E into some will be introduced in the later years. But up to this 0.6 into V square is the power law. That is the power is into some power of 2 or 3. In the third one, in the recent 2015 edition, the PD is the designed wind pressure. KD into KD multiplication KC into KA into PZ. Some research have been given in the some rational formula. The directionality factor, the wind is the random direction and the random direction, which have the many directions, cannot be in the 100% of the single direction. It may be changed into from minute to minute or second to second. That is in the cyclonic area, the KD is the directionality factor is taken to the 1. Other sides, it is the directionality factor is equal to 0.9 somewhat. The case is a combined factor. A combination factor means somewhat of the inclined A-type structures are leading to roof stresses. The B by D ratio and H by D ratio, some combinations have been given in the code. So code is given in the, according to the code, the 0.9 to 1 is taken into the consideration. The third one is the area average factor. Because of the large area of the surface in the roofs of 9 meters into 12 meters or 15 meters, the area distributions is the randomization, and it has to randomize, and it is to correlated to the some degree that area average factor and the tributary area average factor. That is the maximum concentration factor has been provided in this IS 875 IS 875 2015 code. These are the some of the wind multiplication factor. Here, what is this? VB is given in the basic wind speed over 10 meters of height of the building, over 1 meter, 10 meters height of the any structure, up to the, that is the 3-second average wind speed consideration for a period of the 50 years of the, for a 50 years of the any design period, the 50 years period. That is the maximum wind speed. Next. Yes, the maximum. This is the basic wind speed of 33 meters. The wind is divided into the 6 zones. From the zone 1 to zone 6, the 33 meters per second to the 55 meters per second. We are in the zone 5, 50 meters per second. We are in the cyclonic zone 5. This is the basic wind speed 1 meters per second to converted into the kilometers per second, 180 kmph. In the Hudhud, we are the single peak is the 184 kmph. And it is converted into the 164 kilometers per hour when compared to 50 meters. So it is, even though basic wind speed is the gale's wind speed is less than 160 or 180 kmph, but there is so many hazards have been received and we have felt when we are working in working in the Visakhapatnam and Srikakulam. Even though that is why the code committee has introduced the K4 factor, the cyclonic importance factor, based on the cyclonic, there is the importance of the lifeline structures or importance of the industrial economic consideration. These are the 6 wind zones. The 6 wind zones is the basic wind zones. Before that, 1987, before the code revision, there is the 2. One is the pressure map was, next slide. Yes, this is the left side. This is the left side is the IS 875 part 3 wind code. This is the recent 2006 2020. There is a wind map was the basic wind speed map was changed from the 1987 to 2015. What is the design philosophy? What is the history? Before that, we are going into the details. In the 1964, when the wind design code has been formulated, this is the only given in the pressure maps, wind pressure maps. It is the short duration and the long duration. After that, the wind speed map has been changed into the 1987. It is equal to meters per second into the wind speed velocity up to the 6 zones from the 33 to 55. This is the same wind map was introduced and carry forward to the 2015 code. But in the 2016, the NBC, National Building Code, has been revised from the 2005 to 2016. The National Building Code has been given in the some modifications of the basic wind speed map. That same wind speed map was introduced or provided in the amendment of the 2015 wind speed wind code in the 2020 as the amendment 2. In this area, the Delhi and above, that is the left side, this is the saffron color, has been changed to 47 to 50 meters per second. That is the wind speed has been increased from this 47 to 50 meters per second. And at the same time, this yellow has been, this yellow and blue has been, some area has been in Raipur and some area has been decreased. from the 44 to 39. But we are the area in the entire area of this coastal districts, same 50 meters per second has been used, and there is no changing in. But this the 50 meters per second has been given in the Delhi and other areas. This is the changes. These changes have been recently brought by the Indian ISA 875 Part 3 code. Yes, this is the sum of the basic wind speed cities. In this Lucknow, Bareilly, Delhi, Amritsar. Basically, they are all the wind zone 4. The wind zone 4 have been uh, increased from the zone 4 to zone 5 in this Delhi, this Lucknow, Bareilly, Moradabad, Patiala. These things. And the Impal, Manipur, and Jharkhand, Madhya Pradesh, Uttarakhand, the Dehradun, Almora, they have been brought from the 47 to 39 meters per second. These are reduced. But during the Delhi, Amritsar, Bareilly, and other all the Lucknow cities, they have been changed from the lower zone to the higher zones because of the risk have been increased. Because of the risk have been increased, the existing structures stability has to be calculated, and the new structures has to be designed with respect to the basic revised wind speed of the 50 meters per second when compared to the previous 47 meters per second. Yes, these are the wind speed. These are the wind speed multiplication factors in the surveying or the nature, anything, any design, even in the architecture, we have from the whole to part. Whole to part, we have to broadly provided in the area. This is the basic wind speed of the VB, and the multiplication factor based on the design of the structure, topography, and situation of the structure, the purpose of the structure. The K1 factor is the risk factor. Risk factor means the reliability of the non-exceeding the designed maximum wind speed for a period of certain 50 years period. 1 minus 1 by T. This is the 1 by T is the non-exceeding period of the design period. And the second one is the life of the structure. The life of the, with respect to the life of the structure, the design life of the structure, this is generally given in the 50 meters per 50 years. The risk factor is 1. In case of the temporary sheds and the boundary walls, this is given in the temporary sheds of 5 years design life, and it is the 67% of the 0.67 of the percent 0.67, and the K4 is that total wind speed is already less than the design wind speed of the 50. In case of the important buildings, hospitals or telecommunication towers or the electrical towers or HT line towers, the design life is provided in the taken as the 100 years. It is the 1.08. 1.08 means 8% more than the risk factor of the 50 years. But we are choosing when we are academics, it is the only 8%. But after designing and the calculations, the base bending moment or the top deflection, that the accelerations are the very much increased when compared to the 50 years. These are the because of the structure stability, even though it is the 8% of increase of the risk factors, the overall percentage of the output is very more when compared to the 50 years. So second one is the topographic and terrain factors. The topography and terrain factors means the terrain and topographic means the where is the structure has been located, because of the basic wind speed was given in terms of the open level category 2 terrain only. These are the 4 terrains from category 1 to category 4. Category 1 is the open sea. This is the sea coast, 0 to 1.5 meters height of the structures, less than 1.5 meters of the structures. The category 2 is the 1.5 to 10 meters of the structures, but there is no closely or the sparsely structures. Only there is a plain of the trees are the sparsely located houses. And the third one is the semi-urban, that is the suburbans or the woodly structures. This is the up to the 10 meter height of the structures, closely spaced. And the fourth is the highest, the industrial structures. The industrial structures is the 25 meters above the building height, because when compared to the category 1 to category 4, the highest wind speed or the wind damage on the category 1, because of the wind velocity profile is very broad width when compared to that is the category 4. Category 4 is the category 4 is the city structures where there is the wind velocity disturbance or the impact of the single structure is very less because of the interference effect and other things. This gradient height is very high. But in the open sea or the open level countries, this is the wind velocity is the directly impact because of the single structure is available, no other structure is available. That is why we are open sea structures are the category 1 and 2 are the K2 factors are the very, very high. This is the reverse. That is why it is that is the height of the gradient wind means height of the that is the gradient wind means change of the velocity from the ground level to the up to the maximum height. That is the constant mean wind velocity. That is the flat terrain, open terrain, suburban and suburban. That is the height up to where that gradient or the wind is normally the gradient is carried into the normal winds. This is the category. This is the terrains, the K2 factor variations. The K2 factor variation generally taking in the terrain 2. Terrain 2 up to the height of the ground level, it is the 10 meters. It is the 0 to 10 meters height. That is the 3-storied buildings. The 1-story building is the 3 meters. 3-storied building is the 3 into 3 is equal to 9 meters. Up to 10 meters terrain, it is the terrain 2. 1. In case of the terrain 1, that is the in the Visakhapatnam or anything which is the sea coast, it is the 1.05. It is changing from the 10 to 500 meters. And the terrain 3 and terrain 4 in the closely spaced industrial areas, this K4 K2 factor is already less when compared to the terrain 2. Terrain 2 is the basic wind speed design factors. Basic wind speed is given based on the terrain 2 only. So this is the K3 factor. This is the topographic and the slope factors. This is the factors when it is used. This is used only in case of the structures are constructed in the outer space or inner space of the any hills. Mainly the structures where there is the telecommunications or the HT line constructions have been provided throughout the India. Throughout the India is not in the flat surfaces. They are providing in the so many of the Eastern Ghats and Western Ghats and other structures. Because of this is the K3 factor is generally used for the HT line tension, HT line telecommunications. It is not telecommunications. This is the HT line electrical towers. It is for more than 3 degrees of slope. But generally, our 3 degrees of slope means tan theta should be the greater than of the 3 degrees. Up to the 3 degrees, there is no effect of this K3 factor. So this is the K3 factor. This is showing that one tower is provided on the hill and the second tower is provided on the low hill. When compared to the uphill to low hill, there is a reverse of the low. The upper structure has been in the uplifted when compared to the lower structure because of the gravity of the loads. The loads have been transferred to the lower height structures when compared to the height. That is why we have taken into the K3 topographic factor usage. So this is the K4 factor. This is the recently introduced in the 2015 code when compared to the others. Before that, CD37 is the one division, Indian standard division, which has provided in the cyclonic structures only, especially for cyclonic structures. In the before that, 1987, 1987 and 2000. Before these 1.15 and 1.3 factors have been already introduced that cyclonic sheds and design of structures. But this was introduced in our code. This is the 1.15 and 1.3 is given in the structure that 15% is increased when compared to the normal structures for the purpose of the economic consideration. That is the industrial structures. Only economy is damaged, but not the personal damages. In case of the 1.3 post-cyclonic importance means there is not only economic, there is the destruction of the life. Second one is the destruction of the communications. Other things have been consideration of 1.30. This is the where CS means cyclonic storms. This is the cyclonic storms. There is a severe cyclonic storms, and this is the map where from 1983 to 2015. How many cyclonic storms? How many severe SCS means severe cyclonic storms? 1 minute. Have been hit. And giving that in 1977 the Divisema cyclone. This is all the more and dangerous, and this was the so much of the damage was received and occurred. So much of persons have been displaced from the existing Krishna district. So after that, after the VZ, the velocity at the height of the Z, VB multiplication K1, K2, K3, K4, these are the factors. How the wind loads of the buildings. The wind load in the static wind load and the dynamic wind load. In the static wind loads have been in the for the rigidity of the structures where the time period is the less than the 1 second. These are the rigid and stable structures. In this structures, there is a building as a whole. The building means side walls, total structures have been taken into the consideration. Building as a wall, one criteria. Second one is the individual elements, that is the roofs and walls, because generally the walls, our property line walls, our compound walls has also to be designed with respect to the wind loads only. We are not generally we are not designing if this is the 1.8 meters or 2 meters, but up to the 0 to up to the 12 meters height, this is the force factor is 1.2, 20% more than the general wind speed may be considered for the design of the our walls, that is the compound walls. This has to be considered to the for the structures. Third one is the individual claddings. Claddings including glazings and fixtures. These are the, when compared to the building as a whole, individual structures, these the pressure coefficients are more. That is the 0.9 or 0.95 or 0.95 or 1 is also considered when compared to the others. When these 1 minute. Sorry. That is the fixtures and the glazings are the very more important, because the asbestos sheets or the zinc sheets are blown away by the so many of the cyclonic period. So the wind, that is the in the first or the third slide or fourth slide we have given in the pressure coefficient method, and the second one is the force coefficients method for the buildings. In the pressure coefficients method, the inclined roofs, A-type roofs, or the gable roofs, or the some lean-to roofs, or the single side roofs, we have provided in the external coefficients of the internal coefficient. The external coefficients, the CP external coefficients of always based on the shape of the structure with respect to width and roof angle. These are the structures. The internal coefficient is according to building permeability. Building permeability means how much openings are there. That is less than 5% of the opening, the doors and windows. It is a 5 to 20% medium permeability, greater than 20%. That is the high permeability. According to the permeability characteristics, internal permeability characteristics, CPI was determined given in the code. This is the A means of the frontal area, exposed area. PD is the design wind pressure. So this is the wind loading on the inclined. So when it is the wind is blowing from the left to right, the left to right means the blue indicates left to right. That is the positive indications. And at the same time, the gabled roof was a suction. Suction means the blow away from the structure. And at the same time, because of the internal pressure, this is the right side. Left side is the base. The wind speed on the from the left to right. It is the only external wind. Because of the permeability, there is the internal pressure has been created, because based on the permeability or the amount of opening from 5 to 20%, the suction has been generated. It is the right side, and the same suction has been generated on the lift on the roof also, because of the suction has been generated because of the uplift and blown away by the claddings or other structural members. If it is not provided in the connections basis, generally the connections are the very important of the steel buildings when compared to the RCC and other things, because of the connections are the, if it is connections are the correct and perfect, only 1 minute. only the cladding has been blown away. Otherwise, the members have also been damaged. So that is the only wind pressure on the with respect to buildings. How the wind profile or the wind actions have been considered for the design. This is the left or right. This is the wind. Wind have been the impact of the wind has been provided into this this figure. This is the red lines have been in the. This is the away from the one is the. This left to right is the impact on the positive side. This is the right side, which is the negative side, suction side. This is also suction. This is also suction. This is also suction. This is also positive. Only this is the pressure. Because of the pressure, and it is the pressure and the suction. The positive and the negative, the algebraic sum of the positive and the negative the consideration for the final consideration of the design of the any building part or whole. So force coefficient method. Force coefficient method means individual frames, members, buildings. The force coefficient means generally the walls, the compound walls. Second one is the any hoardings, any telecommunication towers, or anything which are considering there is no internal and outer side, even though the four internal outer side. Any? Pardon? Sir, shall I continue?
Yes, sir. Please. Yes.
Okay, sorry. Okay, this force coefficient was one the individual members. Individual members, whether it is the solid members or the some solid members or the other members, we are taking into consideration of the force members based on the only depending upon the type of the structures. The structures are the walls, buildings. Only buildings means building walls. Second one is the telecommunications towers. Third one is the electrical towers. In the telecommunication towers are four-legged, three-legged, monopole towers. Whatever the towers we have in the because in the monopole towers it is the circular tapered times, and third, three-legged and fourth-legged there is a more space and the solidity ratio, that is the wind is blowing from the upper to right. There is no interference. But in the section also we are taking the code has been given in the norm of the force coefficient method. So this is when I was doing in my PhD. There's so many apprehensions have been given in the newspapers, the hoardings. Because why this is provided in this slides. The hoardings have not been considered as the permanent structure. One thing, because of the hoardings or the temporary structures have been considered the design period of the 5 years. Even though this design life is the 5 years, we should have consideration of the 50 years of the design period. Otherwise, hoardings design is not compatible with our regular structural design. Even though the members are very very good, the embodiment length or the stability of the structure, their stability is not up to the mark. That is why they are the very very flexible structures. They have already been damaged because of the even low winds. Because I am also personally experienced in the Titli cyclone in the 2018 when it is hit in the north coastal district of Tekkali. When I was working in the Deputy Executive Engineer Irrigation Department, the building which side by side I am residing in the second floor, the third floor building beside me, there is the 15 meters by the 6 meters height of the tower was that hoarding was collapsed, and it is twisted. Even though the structures, the foundation height and depth was the 1.5 meters by 1.5 meters, they have given provided in the structures for the stability of the only members only, but not including in the slab. There is no connection between the slab and the structure. Only the structure have been provided with the 1.5 meters by 1.5 meters. This is a huge structure. We have the slab was also cracked at the center of the slab. This is also personally experienced. These are the not when we are seeing there is no damage, but their severity is the very very high because of the impact loads and the gradually loads is the very very more difference, more than 100% difference when we are providing in the W in the gradually varied layers, the maximum load is taken in the triangle, 1/2 or the 0.5 are the taken. When we are the impact, direct impact, we are taking in the 100%. But in the gales, more than 100%. That is why they have been concentrated, recently have been concentrated for these holdings. This is the right side. This right side is giving in the, this is the embedded in the 1.5 meters by 1.5 meters. But there is the no anchorage between the slab and the structure. That is why these are the only prone to the wind gales. So Hudhud cyclone, when I was in the PhD, during my PhD, these are the at the Visakhapatnam also. These two are the Visakhapatnam damages. We have taken into the, we went to the site, we take the photos also. And at the same time, we are taking from the internet also. So some designs, because of the water tanks, petroleum tanks, hoardings, boundary walls. In the water tanks were not specified in the code, but we have to take in the 100 years of the design period. Because of the water tanks was damaged, the water was not supplied to the basic amenities, but it should be the considered the 100 years of design period. This petroleum tank is also hazardous, more hazardous. That is why we are taking into the consideration of the 100 years. The hoardings were not mentioned in the code, but we have taken into the design life of the 5 years. But we have to consider, presumed it as the damaged, even though it is the 5 years of design life, but we are presumed to the damaged is more. Hence, we have to consider for the 50 years of design life. And at the same time, in case of the cyclonic region, we have to provided in the 1.15 or 1.3 based on our requirement. The boundary walls, already we have discussed it. The boundary walls, even though up to the 1.8 meters, the boundary wall maximum height is 1.8 meters or 2 meters. Even 2 meters also, even though this is the boundary wall, design life is 20 years or anything, we have to consider for the design of the wind load designs has to be considered in this boundary walls also. In the cyclonic factor was already represented. Why this is cyclonic factor represented means expected, unexpected, more gale wind speeds when compared to the normal wind speed of the 50 meters per second. That is why they have provided in along with the other international codes in line with the recent research formations. This was provided in this code. So this is the sum of the hudud, that is 2015 filing, that is so many of the Titli cyclone, Jal cyclone, Nelam cyclone, so many of the cyclones. Every year 2 to 3 cyclones have been received, or the damages have been occurred during the period of the July to September for the north coast Andhra Pradesh and the southwest monsoon or the northeast monsoons, and Tamil Nadu also the one of the victims for the cyclones. That is why we have to take into the consideration for cyclonic factors more severely when compared to the east coast and the west coast. East coast has the more cyclonics when compared to the west coast. That Bombay to that Kerala, because of the SST means the sea surface temperature variations is very less in the Arabian Sea when compared to our Bay of Bengal. That is why more cyclones. 1:4 to 6 4 to 6. One cyclone in the year, any year we are taking in the one cyclone in the Arabian Sea. Then at the same time, 4 to cyclones have been hit in the our east coastal area. That is why east coast has the more prone to the cyclones when compared to the west coast. So this is external and this is external coefficients. Because of the external coefficients, we are taking the suction. The suction external coefficient CPE is the whether it is the suction or the positive side. The wind load or wind pressure is always taking into consideration perpendicular to the surface of the any surface consideration. Up to the code in the IS 38, the design of the structures, design of the roof trusses have been in the ISSP 38. The maximum slope is the 11 degrees to 84 degrees, that 18 degrees, that is up to 20 degrees. There is no problem. There is up to 20 degrees. The always in the CPE is the negative. In case of the greater than 20 to 20 degrees, the CPE external pressure is acting on the perpendicular to the roof slab, roof, it is the positive. That is the more impact on the slope of the roof slopes. That is why this is the h by w. H is the means the from eaves to ground level. H w is the width of the structure. H by w is equal to less than, means high. Width is high, width is the large, height is the 50%. So the height is, when the height is less, so it is the more stable. When height is more, non-stable. Simply non-stable means this even the 1% of 2% of increasing of the roof slope, they are more prone to the wind loads. That is why we are giving in this slide. So gust factor method in this, when compared to the static loads and dynamic loads, the gust factor method was one of the methods. Even though in the 1987 code has been provided in some factors, in the 2050 some rationalization have been provided in the gust factor method. In this gust factor method, how the up to the height of the building, up to the 20 less than 20 meters of the building, low rise buildings. The buildings means even the buildings we are taking into consideration of the RCC and the steel. The steel even less than of 9 meters of the height, we are considering the more prone, because of the steel structures are the more prone when compared to the RCC structures. In this, and the code has been up to the 20 meters, up to the less than 20 meters, 20 to 50 meters is the low rise building, above the 50 meters is the high rise building. This is the gust factor, means dynamics. In this dynamics, we are considering the generally what are the dynamics means. First one is we are earthquake, structural dynamics, wind, that is the aerodynamics. Third one is the flight dynamics, the free rigid body movement on the air. These are the three types of the dynamics. Because in the steel code, we are the effective length of the columns have been taken, one end is fixed, other end is free. The second one is the one end is hinged, other end is free, and the fixed and both ends. But at the last criteria, both ends are free. When it is used, the both ends are free. This is the aerodynamic, that is the flight dynamics. The column means the aeroplane is taken as the column, both ends are free in the fluid. This is the rigid body motion on the flight. That is why our steel code is not for the civil engineers. More that civil code, the the steel code has been more prominent for the aeroplanes and aeroplane design and airspace also. So in the along wind direction, there is a crosswind, torsion. These are the two also to be consideration into the for design of the structures. But when we are designing the along wind direction, that is the gust factor method. Only along wind direction of the wind is consideration for design of the gust factor method. Only these are the sufficient for providing the lattice structures, lattice towers and high rise structures. So this along wind response means the gust factor method was consideration for the height of the building. S is the level at which the action effects are the calculated. In this GB and GR, this G is the gust factor when compared to the static method. G factor is the one is the added. This is the more wind loads have been, because of the flexibility of the load, more demand of the wind loads have been considered. The capacity is also to be increased. Because of this, the plus, this is the left side. This is the slowly varying compound. BS means background factor. This is the H and GRS means this is the resonant factor. This factor is considered below the natural response of the structure because of the low speeds. Then come, that is the flexibility of the structure or the rigid structures. We have to taken in case of the time period is less than 1 second, or the taken into the frequency of the high rise structures, the flexibility is less than or the 1 edges, or the height of the structures to minimum base width is less than or equal to 5. That is means height is very high, base width is 5 meters, because the maximum base width is 15 meters to 20 meters of the high tension towers. So the towers is the 30 meters side. 30 meters by 5 is equal to 20. So H by B is equal to more than 5. it is also flexible. Third one is the natural response of the structure is less than or equal to 1 second, less than or equal to 1 hertz. That is the more than 1 second. The more than 1 second means the flexibility is oscillating. They are the not rigid structures, so that their demand of the load demand is very high, and the capacity is to be increased according to demand. So gust factor, this is also gust factor semi method, which was introduced by the even 1987, but the GV and GR some factors have been additionally introduced. In this resonant factor, the HS into resonant factor, in this at the resonant factor, the structures, the damping ratio, like the earthquake code, the damping load also, the damping factor also be consideration. Both these structures, uh, uh, both these values are combined. We have to find the at each level. It is the level. It is in case of the 30-meter site, we have to consider that every 5 meters, every intersection points of the lattice towers, or every point where we consideration, that is level at which they are calculated. This is the recently added in the 2015 code. Before that, only the gust factor method was gust equation have been modified. So how these variations of the gust factor? Because this is the blue line where it is that 1987 code have been provided in the plus 2.5 to plus 3 somewhat. This is the gust factor is increased from the height to down, because the consideration is less when compared to the others. This is shown in the less, but overall factors, the G is less, but the overall factors, the VZ factor has been increased because of the height factors, the turbulence factors. Overall method is 1 plus G into somewhat into R into this is more than the static wind pressure. So wind pressure variations, even though the wind pressure variations, what is the static wind pressure and the dynamic wind pressure? So finally 1 plus G into this pressure is PZ. The PZ variations. This PZ variations, blue is the static wind load, the dynamic wind load at the zero level. The zero level means at the height of the 0 to 5 meters height of the structures. When compared to the 5 to 10 meters or the 20 meters, this is the right side where this is the static wind pressure based on the sand, and this is the dynamic wind pressure. G is when compared, that is the flexibility method, flexibility of the structure, height of the structure increases, the gust factor, total gust factors also, that wind pressure at the 30 meters level. This is the wind pressure at the 5 meters level. This is the wind pressure at the 5 meters level. Left side is the 5 meters level, right side is the 30 meters level. Height is increased, the dynamic factors or the other factors are increased, so that there is the three internal parameters have been considered. One is the top deflection, second one is the bottom bending moment, third one is the acceleration. These three have to be determined as a internal parameters for the design of the any tall structure. These are the primary. The remaining have to be checked and designed according to the situation. So these are the telecommunications towers. These are the four-legged towers. These are the four-legged means 1, 2, 3, 4. These are the four-legged towers. These are the some of the structures. This is the 5 meters. This is the 20 meters. These are the 30 meters. Even though a small increase of the load can increase the wind speed to the power of square, because of the V is P 0.6 into VZ P is equal to VZ square. So even though small load is provided on the any part, the wind speed is increasing into the square of that is the parabola. That is why we are considered, these are the flexible structures we have to consider for the greater care. So this is the Varda cyclone 2016, during when we are taking from, this is also from the internet also. So this is also internet I am taking in this. This is also cascading effect. When we are taking in the electrical lines, one pole is damaged, other poles have been to be damaged. It is the catastrophic. These catastrophic effects have been considered for the design of the electrical towers. This is the greater care should be the taken for the design of the structures. So this is the tall buildings. This is the, when compared to the tall buildings, that is the height of the structures is less than 20 meters. So this is less than 20 meters, 20 to 50 meters, 50 to above high-rise buildings. High-rise buildings are considered as the tall buildings. When they are the tall buildings, windy, these structures have the bluff body aerodynamics. Thus, bluff body aerodynamics. The basic structure is giving in the this type of the elevation, but other structures, the tapering, twisted, setbacks, and openings have been considered free flow of the air. Because of the free flow from the internal permeability upper, the upstream to downstream side, the wind effect is less. Otherwise, the wind effect is increased. The uncomfortability of the uncomfortability of the persons who are residing in the offices or the houses, and at the same time we are also the structural stability was instability was occurred due to the heavy wind pressures. That is why when the tall buildings they have been provided with the some wind aerodynamics, smooth flow, tranquility of the floor when compared to the interference effects. And the second one is the impact is impact of to slow down the impact. We have to the slow down the turbulence. Turbulence means when we are in the meeting in the any two impact, there is it means the turbulence. So this type of the buildings orientations have been considered for design of the tall structures. So these are the some of the internationally available 2717 structures, Burj Khalifa, and up to the towers of Malaysia, 1483 structures. These are the some structures have been, how the structures and the stove, how the structure elevations have been considered for the smooth flow of the airflow of the stability of the structures. This is the one type of the, this is also taken from this internet also. So these are also some type of the structures. These are the elevations for the black body aerodynamics. This is the third. This is the so much of openings. This so much of openings. Because of so much of openings, they have considered the from upstream to the downstream side, so that there is the smooth flow of the laminar flow, so that they can reduce the structural cost and increase the structural stability. This is also one type of, that is the oval shape. This is also claddings, and this is the top opening. This is also somewhat triangular shape. Some pattern has been provided. So this is also CFD diagram. How the CFD diagram has been provided, because of how the claddings have been provided. How this, once the CFD, the ANSYS fluent to CFX or other softwares have been they used for computing this external factors, interference effect, and other effects, and up to the and what extent the building damage have been studied. So sorry, this is so this is one thing. This is the right side. This is the left side. How the plan view and the, this is the elevation view. This is the plan view. How this plan view and the wind is this direction. How this wind is blown from this direction to this direction. This is the perpendicular. This second one is wind is blowing this direction. This is the corners are cut down. There is a haunches or the smooth flow, so that the wind was traveling from this to this, traveling this to this, so that the effect was very, very less. This is the ABL, atmospheric boundary layer. This is generally the atmospheric was the pressure difference and the temperature difference, but wind engineering has been taken into the mechanical considerations of the atmospheric boundary layer. Because of the mechanical consideration means only force and the impact, not we are considering into the pressure and other things. Only we are taking adiabatic temperature, we are not taking. We are only mechanically impact of the how much of the wind is coming and what is the impact. It is the impact and other things. These are the wind tunnel testings. The wind tunnel testings have been provided, and in the SCRC Chennai Structural Engineering Research Center lab, one is the one of the excellent lab. I have visited and see the 2 to 3 times. And the second one is the RWDA, is the internationally famous structural engineering wind tunnel testing. They have also, this is the wind tunnel testing. This is the structures. What is the terrain? That is the topographic factors. The topographic factors category 1, 2, 3, 4 have been provided based on the situation of the structures. According to the situation of the structures, they have stimulated. This is the wind blow from 3 to 10 meters per second or 30 meters per second. What is the wind velocity? Wind blows have been provided in the windmiller fan. According to this, the structure was stimulated into the either 1:50 to 1:50 or the 1:60 scale, so that how the characteristics, these are the small structures where it is the provided in the topographic factor of the category 2, 3 or 4. According to situation, the stability of the structure, modeling of the structure, shape of the structure was determined. So these are also some of the structures, the modeling, physical modeling and other modelings have been in the wind tunnel testings. So this is the wind, this is the basic form, means this is the rectangular plan. This is the rectangular plan. How the corners recession, in case of the plan, in the elevation, how the corners have been recession, so that the wind have been one of the corners recession to reduce the wind loads. It is the corners corners cut. The corners cut means this is the haunch portions. This is the corners slot. This is the corners slot. This is the corners roundness. Because these are the corners roundness. This is the, when compared to the bluff body which edges, this is the one type of. This is the elevation. How the curvilinear form. These are the setbacks. These are the setbacks. These are the taperings, and these are the top openings. This is the twisted form. How it is provided in the twisted. These are the some of the basic knowledge we have to acquire for wind tunnel testing or the small high-rise buildings. So up to this, I may conclude this presentation. Hope
Thank
you
you, sir.
enjoy the presentation.
Yeah, of course, sir. Thank you very much, sir. Sir, if you allow, I welcome the participants for question and answer session, sir.
Yes.
Yeah, I request all the participants, if you have any question, you can unmute yourself, and or else you can place it in chat box. Sir, there is a question from Nagarajan, sir.
Okay.
How can emerging technologies like wind tunnel testing, computational fluid dynamics, and AI be integrated into the wind load considerations outlined in IS 875 Part 3?
Yes, they have already been in the research gate and other papers. There are so many papers have already been read. Because of this data, the artificial intelligence or the deep learning or the ML, these are the data. The data have been in the internet. We have taken from the internet. We have to stimulate it in the internet, because of the machine learning is the one of the advantages. Excellent methods, though the statistical methods, so many of the statistical methods have been studied by me also. I read also, I participated in the machine learning and deep learning technologies and deep learning. So much of neural networks and the machine learning algorithms have been provided in this actual Python and other softwares. We are taking all the data from the existing data. You have to stimulate from that to our consideration. There are the excellent when compared to the previous generation. These are the generation of the Z. In case of the artificial intelligence, these are the artificial intelligence era. So we have to very crucial and very so much exact message have been taken, and the outputs have also been taken. But before that, we have to learn the basics very excellent. Otherwise, software not give the wrong answer. But we have to provide, we have to feed in the wrong. We have to provide it in the data in the wrong, when we have to conclude ourselves in the wrong direction. That is only the problem. But because of this, we are only correct to consideration of the code also. Code compilation. Codes are the prescriptives. Like a doctors have been given in the code, has been prescriptive for the so much of tablets and so much of injections, so much of tonics. This is also code has been given some prescription. But understanding of the code and art of the code, that is usage of the code, is very important. That is the art. That is the science and art. Usage of the code at the site is very important. That is the understanding, utilization, and exact point where it is important is the consideration. That is the only the our part only. But we have to study and interpret it, and we have to learn it so many of the times, so that we can understand when compared to the dead loads and live loads. I guess the part 3 wind load is the like an earthquake code. This earthquake code, these are the so much time of the we have to learn it, and we have to understand it. Then we are the AI technologies, ML technologies, and that deep learning technologies have already been excellent usage. But you have to provide sufficient data and correct data, correct interpretation, correct methodology of the statistical methodologies. These are the methodologies. So many books, J.D. Holmes and Simusula, so many international books have been Taylor's and John Willie Taylor's books have been freely available in the net, so that we have to study it.
Is there any
So
other
some
question?
are
How does IS 875 Part 3 handle the effect of terrain categories?
a minute. Yes, sir. Yes.
Sir, there is a
Yes,
question. There is a question from Nagarajan.
yes, okay, no problem. The terrain category, the IS 875, first of all, I inform you that the IS 875 part 3 is giving in the broad spectrum category, topographic category 1, 2, 3, 4. One is basic at the edge of the sea coast. Second one is the up to the of 1.5 meters height of the structure. When you consider any house or the any building, up to the your house is the your building is the your industrial building is up to 1.5 meters of the height. In the around the locality, there is the no buildings have been given in the locality. You have to take in the consideration of the category 2. In case of the 1.5 to 10 meters or the 10 meters to 25 meters, it is the closely spaced. This is clearly giving that is the closely spaced industrial, semi-urban, and the sea coast. These are the 4 categories. They are clearly mentioned, and I am also my presentation also given in the clearly mentions. When the situation of the structures, we have to be considered where the structure is considered. That place has to be identified. According to identified the structures, the topographic factors has been considered. That is the enough. Yes, somewhat Nagarajan MG. The basic wind, that is first of all I am also giving the from the surveying part, because of the we are nature, the surveying or the wind engineering or the something else, we are come the whole to part. The code has been given in the broad spectrum from the 1843 to 2013 or the 1843. There were the anemometers given in the entire India. They are considering, they are statistically analyzed in the Gumbel variations, GV Gumbel extreme variations method. They have considered in the basic wind speed of 50 meters per second for the category of the some consideration of the wind speed. They are providing in the based on the aerodromes. Aerodromes, in the aerodromes or airports, they have the wind anemometers and wind anemographs. Second one is the IMD, Indian Meteorological Department, and other stations have been provided in this based on the statistical analysis. They have considered in the 50 meters per second or the 33 meters per second. Their long run, there is the 50, not in the 50 meters. There is 100 years of from 1843 to the. Please see our the basic wind speed. The bottom is kindly giving the notes that there is the 1843 to 1963. From 1863 to some 1957. Some data has been taken and consideration for this for consideration giving the basic wind speed.
Is there any further questions from the participants?
Sorry, any questions? Anything? Last question. Still, how can we emerging technologies like wind tunnel testing? So first thing is CFD, ANSYS, Webster or ANSYS. safety, computational fluid dynamics. You have to provide it in the ANSYS, CATIA, anything. You have to. ANSYS is not the wind tunnel testing. Even dentists also using in the ANSYS testing. The ANSYS means giving that our stress into strain. You have provided in the model. Even in the dams also, everything. The provided ANSYS primarily ANSYS was in the for the mechanical students, but ANSYS was for the better life. That is like our what is cell phone like. ANSYS is also cell phone like, but we have to use like it Python. Python has Anaconda or the Python has the so many of the libraries. But whatever library we are want to, we desire, we have to download it. Similarly, in the ANSYS also, whatever want, whatever desire, computation fluid dynamics, we have to provide that and to provided this software, and we have to provide it based on the, even though software has been given in the some physical model studies. Physical model studies, wind load test, wind tunnel testings have been provided in the ABL. Because of the ABL means atmospheric boundary level, these are the low wind speed velocity. When compared to the, there are the two types of wind tunnel testings. Because of civil engineering, only ABL, atmospheric boundary level terrain category 1, 2, 3 was provided. In case of the aerospace, more wind load, even supersonic, more than the wind speed. That is why this is the rigid body motions of flight motions. That is flight means flight dynamics means both the ends of the that airplane was in the free. That is why more concentration of the force was taken into consideration. That is why that is giving them the more. That is the wind tunnel first, then the aerodynamics. That is the very fast and different from the our is the atmospheric boundary layer consideration for the wind tunnel testings for our buildings.
Sir, there is a question from Krishna Rao. Could you please?
Okay. Okay. Sir, what is the question, sir? Please let me know.
Yeah, 1 minute, sir. Design of the structures. Yeah.
Design of the structures to mitigate the wind vibration, especially especially in sensitive or highly populated areas. Yes, sir. That is why we are providing. There are the two types. One thing is that you have to provide in the K1 factor, risk factor, increasing of the risk factor. Second one is the gust factor. Third one is the structure design and the application of these factors have been considered because of the gust factor method. You have to provide, you have to choose the variations at the level of variations, a level of consideration, where the ground level is your consideration, or the mid level consideration, top level consideration. You have to consider, you have to design based on your requirement. That is why in the so many, that is why I emphasize that hoardings, the temporary structures and the compound walls not being dealt in the academic books, but they are the practically visible, and so much of damage has been in the occurred during the our so many of the cyclones. That is why I am specially emphasizing on the stressing on the hoardings and compound walls. Even compound wall is not hazard, but we cannot provide in the more value or the more money for damage of the structures. We cannot provide again and again for the damage of the structures, which it is the faulty design. Because we are the last that sir, by mistake I have submitted sir something. And the last one from my side is we are the engineers. The probability of the engineers of the, when we are in the Belmouth code, the reliability of the engineers is 95%, and the reliability of the doctors is the 5%. That is the characteristics of the dangerous is the doctors is the 5%. But we are our responsibility is 95%. That we have to provided. We have to consider the code very meticulously. Still, it is not updated, sir. What?
Yeah. It's not
okay.
question.
No problem. Still, any questions from any questions or anything?
It seems no further questions, sir. Sir, thank you very much, sir.
Hope you enjoy it.
Of course, sir. Thank you for taking the time to be with us and for your invaluable guidance. We
Ayyo.
hope to have the privilege of working with you again in future, sir. Thank you very much.
Thank you. I shall leave it. Thank you.
Yes, sir. Thank you, sir.
Okay.
Dr. Rohan, are you there?
Hello. Yeah,
Rohan,
Raghu sir,
yeah.
I'm here. Yeah.
Okay. Could you please share your screen? Are you comfortable now?
Yeah, I'm comfortable. We can start.
Yeah. Professor Shashidhar, are you there? Yogi?
Sir, I'll let you know, sir. 1 minute. Whether sir is available.
Rohan, we will wait for 2 minutes. Professor Shashidhar will communicate to you.
Okay. No problem.
Sir wanna talk with you. That's why.
Okay.
He's the ex-registrar of JNT Anantapur. Sir is the coordinator of this program.
Sir. Raghu sir.
Sir, please.
Previous speaker name is not there, sir, in feedback.
Yeah, sir. We mentioned there. Please check it once.
Now also it is not there. Now only I did it, sir.
Just
The
now I
last
updated.
name is last name Sadhu, right?
Yeah, yes, sir. Santosh.
Yeah, I saw that.
Yeah. Thank you, Nagarajan, sir. Yogi, or else can I continue?
Sir, 1 minute, sir. I just texted, sir.
Yeah. First of all, thank you, Rohan. I think I troubled you a lot.
No, not yet. No.
Actually, it is inevitable. We cannot change the resource person. That's the
Understood.
problem.
Understood. But the good thing is I can able to join, and I'm right now. I'm here.
My sincere apologies to you.
No, not at all. Shall we start or?
1 minute. I will get confirmation from coordinator.
Raghu,
Okay.
Sir, are you there?
yeah,
Yes, sir.
introduce చేసినావు సార్ని
Yes, sir. If you allow, I will continue, sir.
I'll one minute. Yeah, my dear participants, good evening. Sorry for late joining. Actually, due to unexpected, I was in traveling. I could not attend for these 2 sessions, but luckily I was there for the 3rd session. So I'd like to introduce Dr. Rehan Rajendra Deshmukh. He did his PhD Geotechnical Engineering from Sardar Vallabhai NIT, Gujarat. His topic is field and numerical evaluation of geosynthesis, reinforced flexible payments. From Madhurshi College of Engineering, Nasik, and he's having vast experience. His expertise in softwares like Plaxis, Midas, GTX NX, Geo Studio, Ken Player, ITV, and like his experience in skilling towards laboratory like Triaxial, Cyclic Triaxial, all are related to soil, and he is actively involved in field testing also. He is having a vast experience. He worked for Bentley India Private Limited from March 2023 to till date. So he delivered Plaxis and he worked as assistant professor in civil engineering department, MGM College of Engineering, Navi Mumbai. He's a senior engineer. Is having so much experience to his count, and is having DST project also. So now I request I request Rajendra Deshmukh ji to please take over the session,
Yeah.
please.
Yeah. So thank you very much, sir, for this introduction. I hope I am audible and I'm visible also. So, Raghu sir, can I start?
Yeah. I wanna brief. I wanna tell something about you to the
Okay,
audience.
okay,
Yeah.
okay.
Actually, I'm very happy to have this platform with Rohan. Moreover, he's my friend. We work together at NIT. He is having the vast experience in geotechnical stream. He worked as Professor Shahidar expressed. He worked in Bentley. He has been working in Bentley now. Earlier, he worked in McAfee, and he dealt with many soil related problems. I hope we may enjoy this session with his vast experience in landsliding and geotechnical problems. Thank you, Rohan. Thank you for accepting our invitation. Sincerely, I'm asking apologies from my
No,
team.
no.
We trouble you a lot. Thank you very much.
Okay, okay. So now we'll get start. I'm sharing my screen. Currently, right now, I'm using my mobile hotspot. So to save the data, I'm going to off my camera. Okay, so please allow me. Okay, now I'm sharing my screen. Once it is visible, just let me know. I'm sharing my entire screen, and I hope my screen is now visible.
Yeah, it's great.
Okay, I'm just hiding this. Yeah. So, good evening to one and all. Myself, Rohan. So, currently, I'm working as a geotechnical solution engineer or consultant for the Bentley system since last 1.5 years. So, my role in Bentley system is, all of you know that Bentley is actually a software civil engineering software providing company. So, currently in Bentley, I'm managing the geotechnical product like Plaxis, one of the geotechnical finite element software. Along with that, I'm also managing the GeoStudio, one more geotechnical tool. Along with that, I'm managing the GINT, Open Ground, LeapFrog, and many other geotechnical and geological software here in India. So I'm taking care for the sales, business development, technical support, training, particularly for the Plaxis and GeoStudio for the country like India and some neighboring country like Bangladesh, Nepal, and the Sri Lanka. So today I'm going to talk on the topic assessment of rainfall induced slope failure, and we will try to analyze this aspect by using the numerical technique, particularly with the Plaxis 2D software. So this is a typical outline of my presentation. So in the beginning, I'll try to cover some fundamental aspects of slope, different modes of slope failures, okay, the reason behind the slope failures, and then slowly, I'll take you into the technical details of the numerical modeling, a numerical technique that are available to find out these factor of safety for the slopes, and then I'll take you in the how to simulate the rainfall, artificial rainfall inside the software like Plaxis, and how that rainfall actually affect the factor of safety of our critical slope, natural slope, whatever it is. Okay, that I'll show you at the last part of my presentation. And if time permit, I'll quickly take you through the actual Plaxis software, how we can model what the input parameters are needed, and what the different types of analysis that we are using, and the lastly the very important, that is the outcome, how to see the factor of safety, how the saturation get increase inside the soil with the rainfall. So that part I'll try to show at the last. So all we know, these slopes are typically categorized into the two types. One is the natural, and the second one is the artificial or the man-made slopes. These natural slopes, we know how they are formed. There are many physical process like the plate tectonic, weathering, erosion, which takes place, of course, for the millions of years, and finally the slope like structures or the hill like structures or the mountain like structures get formed. Okay, and the material deposition like the sedimentary kind of a rock, that is also one of the reason to which makes this kind of a structure like slope structure or this mountain like structures. And at the same time, there are some artificial or the man-made slopes are also there, that we means the main we created for the to facilitate the infrastructure projects like the road embankment or the railway embankment, or sometimes for the earthen dam construction. So all these structures, if you see, they're having some slopes. Okay, so we can also categorize this as also slope, but as a artificial or the man-made kind of a slopes. Okay, so the stability of this slope is a critical importance in geotechnical, not just in geotechnical, but in the civil engineering domain. When we call the slope movement is happening when there is some when your slope start moving in the downward direction, we sometimes we call that thing as a landslide. That can lead to the several infrastructure damages. Sometimes it may lead to the casualties. Okay, uh, many of us, you know that recently in the monsoon season in the Kerala, a huge landslide happened and almost hundreds of people get died in that one. So because of that reason, there is very important to find out to investigate the stability of our natural slopes or artificial slopes in some cases. So on which factors this stability of slopes or the soil basically depends. So of course, very first is the gravitational force, means the self weight of that soil or the rock material. That is the one thing. And sometimes the additional loads which are acting on our slopes. So some building loads or some other loads which are acting at the top of our slopes in some of the cases, and some scenario like earthquake that also responsible to uh, initiate the dynamic loadings in the our sloping structure. So our slope must be withstand against all these forces: gravitational force, dynamics, and some dead loads coming or the live loads coming on the top or at the bottom of our slopes. Here I'm trying to show you the different reasons or the causes who makes our slope unstable. So very first and the very common is the increased unit weight of the soil because of the weighting or because of the saturation. So pore water pressure comes into the picture, and then the slope may becomes unstable. The second is the some added external loads at the top of our uh, uh, slopes. That also can be one of the reason. For example, this is my slope, and suppose we are constructing some building like structure at the top of this. So this the load coming on the top of your slopes. Okay, and that can be responsible for making the our slope fell like in this fashion, right? So all we know this. Okay, and there are few other reasons like uh, sometimes we are making the slopes quite steep for because by doing some excavation for the road construction and for other purposes, and the natural process like erosion is also responsible for making the slope unstable. And then the shock loads, the vibrations and earthquake, increase in moisture content, and in some areas like in the Himalayan region or in the colder region, the freezing and thawing action is also responsible for making the slope unstable or to make the slope failure. Okay, so these are the few reasons I have just summarized. So of course there are many other reasons are also there, but these are the few more predominant, I can say, the reason who makes our slope unstable. Now I'm trying to show you the typical modes of slope failure. So there is one scientist name is Wons. So in the year 1978, he classified the slope failures in typically into the 5 types. So the first type of failure, according to the Wons, is faults. Okay, so what is the fault? So in this fault, what happens? The rock particle, you can see this rock blocks, they simply get detached from the parent rock and they comes on the downward direction. So this figure 1b represent the actual failure, fall failure, which happens in the Spain. Okay, and the second mode of failure, according to the Wons, is the topples. Okay, so in this case, you can see in this figure 2a, the rock material get detached from the parent rock. Okay, and this rock material, they are coming in the downward direction, but while coming in the downward direction along with the translational, this rock block, they also experience some rotational moment. Okay, so if you compare between the faults and the topples, then you come to know that in the faults there is also rock blocks comes in the downward direction, but in the translational manner, simply comes in the downward direction. And in the case of topples, they are also coming in the downward direction, but along with the translational movement, this rock blocks, they also experience the rotational movement. So that is the basic difference between the faults and the topples kind of failure. So in the figure 2b, you can see the topple kind of failure occur in the Colorado, USA. Okay. And there are a few third kind of a failure is a slide, okay, which mainly happens inside the soil when the shear strength of the soil is of course lower than the shear load that get applied on the soil masses. Okay, and again this slide failure we categorize into two types. So for this is the first figure. You can see this is the you can see the soil mass, they are simply comes down in the downward direction. And if you see the failure zone, it is completely it is somewhat rotational in nature. Okay, so we call this failure, this kind of a slide failure, as a rotational slide. And along with that, you can see in this figure there is also the soil movement in the downward direction. But if you see the failure zone, failure plane, it's a translation, or we can say this simply linear in fashion. Okay, so these are the two types of slide failure. One is a rotational slide, and the second one is a translational slide. And it happens, this kind of a failure happens mainly because of the shear strength losses, or we can say the shear strength of the soil is lower than the applied shear loads. Okay, so there are many reasons why the shear strength get minimized, or why it get reduced. So one of the reason is the water or the saturation. So that makes the that loosen the shear strength, and this kind of a failure happen. And if you wanted to see the actual rotational failure, so in the figure 4, you can see this is the rotational landslide, which happens in the England in the year 1993. And the example of the translational landslide, you can see in the figure 5b in the bottom side. Uh, this is the translational landslide, which happens in the Japan in the year 2016. And the reason, of course, is the seismic activity. All of you know that Japan is an earthquake prone area. Along with that, the different another two modes of failure is the lateral spread. Okay, so lateral spread is mainly because of the liquefaction phenomena. And you can see the example of this lateral spread. Hello, there is someone on. Can you please unmute yourself? Hello, there is some noise actually.
Yes, sir, you can proceed, sir.
Okay, thank you, sir. So you can see landslide, as sorry, lateral spread, as I mentioned, is mainly happens because of the liquefaction phenomena, where the shear strength get losses and soil behaves like in the boiling sand condition or quicksand like conditions. Okay, so you can see in the typical lateral spread failure which happens in the Pakistan. You can see the thorough, a very big crack inside the road itself. Okay, so this is a typical example of the lateral spread, and the reason behind it is the liquefaction phenomena. And there is a last failure according to the Wons, he called as a flows. In the flow kind of a failure, your soil sample in the slurry format simply comes down in the bottom side. Okay, so we call that failure as debris flows, debris avalanche, earth flow, and the creep. Again, some differences are there in this, but I don't want to go into the details. Or what is a debris flow, what is debris avalanche. Okay, so all these things are there in the internet. You can just go and just check it out, because my intention is to focus more on the how to simulate the rainfall in the softest like places. That is our main point of discussion. So now before going into the technical aspects of the this factor of safety calculation, rainfall simulation, I just wanted to highlight the landslide which will happen in our country. Okay, so which gives you why gives you why we need to understand this topic in detail. Okay, so of course, this landslide is not at all new thing for our country. Okay, so this is the news cutout from the year 2022, where you can see the title is Kerala saw maximum landslide in the 7 years. And if you see the picture, it is very dangerous. The whole road get blocked, and you can see the rock blocks. They are complete. The rock comes on the road surface. Okay. This is another news from the Kerala again. You can see the multiple fatal landslide happen in the Kerala. This is the northern part of the country. So not just in the Kerala, but in everywhere in our country, this kind of things are happening, particularly in the rainy seasons. So this is from the north part of our country, and in this landslide, almost 46 people get killed. You can see this soil material simply comes down in the bottom side, and whatever the villages are there on this side, they are completely get dumped inside this soil mass. This is from the Himalayan regions, and almost 50 people get killed in that one. And rain triggered the landslides. So with these all figures, you come to know that the main culprit is the rainy season or the water, which triggers this landslide. Of course, because of the rainfall, because of the rain, the sheer strength of the soil get loosened down, and this kind of failure is happening. This is another from the Maharashtra. Almost 78 people get missed in this tragedy. This is from the Tribun, India part, the Kinnor Road. You can see the road surfaces simply get washed out. Only half portion of the road is now remaining. This is the again from the Himalayan region. 10 people get died in this tragedy, and you can see the rock blocks simply comes down in the bottom side on the road surface. And this is another from the Maharashtra. 12% get killed in this. Okay, you can see this in these photographs. This is from the Sikkim region. You can see the huge rock blocks comes on the road surface, and now it is completely get blocks. Okay, so now we understood the this landslide and uh, the failures and the tragedies and how much people get died and all those things we now we see now the thing is, what initiatives has government has taken, or whether any guideline is there to estimate or to find out the factor of safety for the critical slopes in particularly. So recently, the Central Electricity of Authority of India, the Hydro Project Monitoring Division, they have published one guideline last year only in 2023. In that guideline, they mentioned the importance of this slope stability analysis. Okay, so this guideline is published by the Central Electricity of Authority of India, so this guideline is applicable for the hydropower project only. But my suggestion is this guideline should be applicable for the other projects also, like for the road projects, railway projects, and many other projects where uh, the portion of infrastructure is passing through this hilly region. Okay, so let's see what this guideline is mentioning, what information. So I have just highlighted the portion from this guideline. I'm just reading this that information from that particular guideline. So let's see what this guideline is talking regarding the slope stability assessment for the hydropower project. So project authorities should carry out a numerical model studies of a vulnerable slopes. Okay, of course, when we are constructing the hydropower projects, this hydropower projects, this hydropower project means is nothing but a dam or the barrier that we are making in front of the water structure, water flow. Okay, and we are choosing a location such a way that it should uh, uh, it should contain more water on the upstream side. Okay, so for that we are constructing the dam like structure on a some sloping portion, okay, where the valley like structure is there. Okay, so of course this dam or the barrier structure, they are resting on some critical slopes. Okay, so that may be on some soils, or that may be on some rock or the fractured rock. So again, the geology and the geotechnical thing is very important in that case. And this guideline is suggesting that this project authorities or the consultant or the construction agency who are dealing with the hydropower project construction, they need to carry out a vulnerable slope slope stability analysis using either a limit equilibrium method or a finite element method or a finite difference method software, of course based on some in situ and the laboratory test result as an input parameter for that slopes, for that software, and then do the analysis. Okay, so this guideline also mentioning the importance of the softwares. Of course, they also mention you need to carry out a proper in situ testing, some laboratory testing on the collected soil and the rock sample, and then use that in as an input data, and then do the further slope stability estimation or the analysis. But now at least this Central Electricity Authority of India, this hydropower division, they comes up with this kind of a guideline. But right now there is no guideline for conducting the slope stability assessment for the other infrastructure projects. Now I am going into the details or the technical aspect of the slope stability analysis. That is our main point of discussion. So the slope stability analysis, there are two ways to do this slope stability analysis. One is the limit equilibrium approach or the limit equilibrium analysis, and the second one is the numerical method of analysis. So limit equilibrium, many of us, you know all those methods which comes under the limit equilibrium assessment. Very common is the Swedish slip circle method. Many of us, you have heard about it, or many of us, you have gone through this method in your geotechnical engineering 1 or 2. The chapter is typically stability of slopes. Okay, then there is method, ordinary method of slices, Bishop's method, Lorimer's method, Spencer's method, Sarma method, and many other methods are there under the limit equilibrium analysis, which I'll discuss in detail in the upcoming slide. And at the same time, as I mentioned, there is another method of, and that is the numerical method of analysis. And again, in that, the three different techniques are available. That is the continuum modeling, discontinuum modeling, and the hybrid couple modeling. Okay. So let's try to see the assumptions and the benefits associated with the limit equilibrium, and then we'll see the finite element method also. That is one of the numerical method analysis. Okay. So this limit equilibrium method is most common, widely used slope stability analysis method. Why? Because it takes very less time to get the factor of safety. But of course, when you're getting something in a very quick manner, so some assumption, of course, are there behind that. So limit equilibrium analysis is also not the in that case also some assumptions are there. So assumption is like that the slope is on the verge of failure and that the forces acting on the potential failure surfaces are in equilibrium condition. So what is this assumption basically? So I'll try to explain with some simple figure. Okay, so this is my critical slope, for example, and I wanted to find out the factor of safety. So the failure may be like this. Okay, circular in nature. Right now, I'm assuming. So whatever the forces that are acting on this, so of course the forces like the self weight of this failure zone, and the other forces is like the shear strength of the soil, which trying to resist this slope failure. Okay, and the weight component of this particular soil mass trying to move down the soil in the downward direction, or this portion of the soil. Okay, so what this limit equilibrium analysis is assuming, so it is assuming that these forces, the shear strength forces, the forces acting in the bottom direction, they are all are in equilibrium condition. Okay, means any one of these two forces get exceed, then the failure happens. Okay, for example, if the forces acting in the downward direction means this, of course, the one of the component of the weight of the soil, failure soil, if it get increased than the shear strength of the soil, then what happened? Of course, the failure get happen. Okay, this limit equilibrium analysis is assuming that these two forces, resisting and the overturning forces, they are in equilibrium condition. But in reality, in actual condition, this cannot be the condition as well in all the scenario. But this limit equilibrium analysis assuming that. Okay. Then, as I already mentioned, you can go with the different methods like the slice method, Felinius, Bishop, Spencer, Morgenstern, Price, where in all these methods, what they are doing, they are dividing the slopes into the slices. Okay, slices means, I guess many of us you know about this, but I'll just quickly show you those who are not new about this concept. What is this factor of safety, slope stability, and the slices. So for example, this is my failure zone. And what we are doing in this limit equilibrium approach, either we are dividing this failure zone in the vertical slices in this fashion, or some cases we are dividing in the horizontal slices. And another thing that we are doing in this limiting, we are trying to find out the vertical forces for each and every slices. Okay, and then we are also finding the component of this weight which makes the slope fail. And another thing that we are finding in this is the shear strength of the soil, okay, which raises the failure. Okay, and how we are determining the factor of safety, it is equals to the overturning moment. Overturning moment is because of the weight component of this slices and divided by the resisting moment. sorry, I made some mistake. It is the resisting moment divided by the overturning moment. Okay, so if the resisting moment means the shear strength of the soil, if it is good or higher, then of course your resisting moment is good, a higher value, and overturning moment is lower. And in that case, you will get the factor of safety more than 1. If your MR is, or resisting moment, or the shear strength is good. But if the shear strength of the soil is poor or very low, in that case, what happens? Of course, your resisting moment factor, this value get dropped, get reduced than the overturning moment, and in that case, your factor of safety value is of course less than 1. And we know that to make our slope stable, our factor of safety value should be higher than 1. That is very obvious thing. And on which parameter the shear strength of the soil is depends. So the shear strength of soil or the rock material is depend upon the cohesion and the angle of internal friction. I hope this gives you some insights about the how we are determining the factor of safety in the limit equilibrium approach. Okay, so I already mentioned that this is very quick method, very fast method, but of course some limitations are also there in this limit equilibrium approach. The limitations are like it neglects the effect of pore water pressure, okay, which is one of the I can say one of the predominant factor which make the slope unstable. So the limit equilibrium approach is neglecting. But now there are some software which also taken care for this effect of pore water pressure. But the thing like the soil deformation and the stress strain value or the stress deformation inside the soil material, that part or that thing you cannot able to get with the limit equilibrium approach. Okay, so when the soil get failed, when the failure occur, or when the slope get failed, of course some deformation is there, right? Your soil mass is comes in the downward direction in some in terms of some millimeter or some in terms of meter also some cases. But that soil deformation value you're not able to calculate in the limit equilibrium approach. So these are the few limitations are there in the case of limit equilibrium approach. So very first limit equilibrium method was developed. We call that method as the ordinary method of slices, which was developed in the 1936. Okay, the assumption behind this method is the resultant of slide forces is parallel to the base of the slices, so which is not relevant in many of the cases, but still that assumption was there to make the equation simpler one. And again, the equations to get the factor of safety is the only overall moment. Okay, so they have used the only overall moment equations they have used to find out the factor of safety. But along with the moment, there are a few other things are also there, like the horizontal forces, the vertical forces, or also the forces which get developed between the two different slices. Okay, so those things were completely neglected in the old method. And another thing is uh, the failure which occur is the circular in nature only. Okay, like this. So this is a slope and the failure is always circular. That is another assumption. The slip surface or the failure surface is circular only. That is another assumption in the older method. Okay, now later on in the the scientist Bishop, he come up with a new equation in the 1955. And along with the overall moment, he also considered the vertical forces, but the slip surface is again the circular. That is another assumption which remains same in the Bishop method. Again in the Janboon, again in the again in the next year in the 1956, he considered the many different things like the overall moment, vertical forces, horizontal forces, and also the slice moment. And the good thing is he considered the shape of the failure surfaces of any shape. Okay, so the shape may be sometimes the linear in fashion or something like this in fashion. Okay, so that is the beauty. Right now still in the real practices, people are using the Janboon's method in for determining the factor of safety for the slope stability assessment, because of the equation and the flexibility that we have in the Janboon's method. And just a second. Yeah, and now after that, many other methods comes into the picture: Morgenstern, Price, Spencer's, and many other. So these are the few methods which people are commonly using and the assumption behind it. Anyways, I'm not going into detail of this. Later on, I'll share this slide. You can go through this, the assumptions for the different limit equilibrium methods. Now coming towards the finite element analysis. So this is a more advanced and sophisticated slope stability analysis method. Okay, and this method is based on the equations of equilibrium, or I can say the constitutive laws of soil material. Like a very famous constitutive law that we are using is the Mohr-Coulomb failure criterion. Okay, in short, we call it as a MC. So that Mohr-Coulomb, sorry, Mohr-Coulomb failure criterion we are using uh, in this finite element approach to find out the factor of safety. Here we are not dividing our slopes into the vertical slices or horizontal slices. We are not doing this. We are using these equations or the constitutive law. Uh, and flexibility that you get in the finite element analysis is that you can do with the plane strain modeling, axisymmetric. Also, you can go with the 3D, three-dimensional modeling inside the in the finite element approach. You can go with any slope geometry. You can put any boundary condition, earthquake boundary, dynamic boundary, any boundary conditions you can apply to your model, and you can go for the slope stability assessment. And another advantage is that you can consider the effect of pore water pressure in your geometry. You can consider water table in the geometry. You can able to get the soil deformations during the failure. You can also able to get the stress strain distribution in your throughout the geometry, throughout your soil material, the rock material. Another advantages is that you can simulate the stages of loading and the unloading. You can simulate the construction stage sequencing. You can do the consolidation phenomena thing. And of course, while doing all those things, loading, unloading, stage-wise analysis, effect of pore water pressure, stress strain analysis, for doing all these things, you need to have a proper input data. You must have the good computational time with you, and of course, the very important is the expertise to understand, to judge the output that you get. Okay, of course, if you're giving anything to your software, your software giving you some output from that input, but there your roles comes into the picture, whether the input data that you have given is appropriate or not, as per the field condition or not. And also the factor of safety that you get is uh, is uh, is similarity is behaving is similar to the actual field condition. That judgment you should have. Okay, so that are the few things. Okay, now I'm going into in little detail of the finite element modeling. What different input data that we need to model this rainfall slope failure inside the softwares like Plaxis. So very first thing is that is the detailed engineering description of the soil stratigraphy. Okay, so you must know the stratification of your soils. Okay, suppose this is my slopy portion. Okay, so what kind of a soil is there at top, what is there at the second layer, what kind of a soil is there in the second, third layer. Like that, you should have the soil stratigraphy. In short, the borehole data you should have. Okay, along with that, you should know the groundwater regime. Okay, means at what location the water table is lying. Suppose in my case, the water table is lying somewhere here. Okay, so that data you should have from top level, at what location the groundwater table is there. So that data also you need to have. Then the another very important is the rainfall data. So how much rainfall is occurring in that region. You can take that data from the local IMD department, meteorological department. Okay, because that data we need to have how much rainfall is occurring on that area. So that rainfall or infiltration data we need to have. Then the saturated permeability, the permeability value for your soil and the rock material, that is another important thing. And then the SWRCC or the SWCC. So this is nothing but the soil water retention curve, or I can say the soil water characteristics curve. Okay, so you can see the soil water retention curve in this figure. Okay, so this theta is nothing but the water content. This psi is nothing but a suction. Okay, and this is nothing but the soil water retention curve or the soil water characteristics curve. And this is this SWCC or SWRC is required when the flow is occurring through a unsaturated zone. Okay, so that I'll cover what is that in the upcoming slide. So this is this blue color represent the sandy kind of a soil water retention curve for the sandy kind of a soil. This red color is for the silty soil, then the green is for the clay kind of a soil, and the violet is for the pit soil. So we need to have this data, the soil water retention curve or the soil water characteristic curve for your soil. Okay, then only you can model the flow through the unsaturated zone. Okay. Okay. Now coming towards the flow model, okay, so flow parameter. So this flow through a soil, okay, suppose this is my slope and this carries some soil, okay. So the flow, which is when the rainfall is occurring, okay, the water start infiltrating inside the soil and this water start moving in the downward direction, okay, of course. So to model this water flow through the soil, we need to have some data like, okay, so when we are modeling the, of course, again, there are two situations. One is the flow through a saturated zone and the second one is the unsaturated zone, okay. So how we are um, taking care of all these two different aspects, because some saturated flow through saturated that we can understood, but how we are modeling this flow of water through an unsaturated soil inside the tool, inside the software like Plaxis. Okay, so for steady state groundwater flow means the flow through a saturated zone, we need to have the permeability value for your soil, the K value. Okay, but when the flow is passing through the partially saturated soil, as I already mentioned, for in that case, we need to have the soil water retention curve or the soil water characteristics curve. Why we need this? So we need this because to model the flow through the partially saturated soil, we are using a very famous equation. We call that as a Van Guchten function, okay, which we are using to model our flow of water through a partially saturated soil. Okay, so let's see what this equation is saying. Okay, so this is the flow, this represent the flow through a partially saturated or unsaturated zone. Okay, and in this is nothing but the residual water content. SAT is nothing but the saturated water content. This GA, GN and GC are nothing but a curve fitting parameters, and this psi is nothing but the suction parameters. Okay, so this equation helps us to model the flow through a unsaturated zone of soil. Okay, so these are the few input parameters we need to give inside the Plaxis tool, okay, as an input parameter, so that we can model the flow through the unsaturated zone. And here we are using the Van Guchten function. I'll show this in during the when I'll show you the Plaxis software. In that I'll show you this part again. Okay, now coming toward the another aspect. Now we understood how we are modeling the flow, the groundwater flow through the saturated zone and the unsaturated zone. For the saturated zone, we need to have the permeability data, and for the unsaturated zone, what we are using this kind of a soil water retention curve or the soil water characteristics curve, which is defined by this famous Van Guchten function. Okay, now the thing is how we are modeling the rainfall inside the Plaxis. So very first, the analysis type that we are using in the Plaxis is the fully coupled flow deformation analysis. So what is this fully coupled flow deformation analysis? That I'll quickly explain. Okay, so this is my slope again. And what we are doing, we are simulating the rainfall. Okay, suppose the rainfall is occurring some on the top of my this sloping portion, and this rainfall, this water start infiltrating inside the soil, and slowly this water start moving in the downward direction. Okay, so inside the Plaxis, what we are doing, we are using the analysis condition like a fully coupled flow deformation. Okay, so we are considering the two phenomena. We are simulating the flow through the soil, and along with that, Plaxis or the software also calculate, because of this flow, how much deformation is occurring in my slope or in my soil. Okay, so that kind of analysis we call as a fully coupled flow deformation analysis. Okay, why we are determining the deformation? Because of the flow, because of the saturation, how much deformation is there, that we need to understand, and based on that deformation we can able to find out the factor of safety for our slopes. And that is our main point of interest, that is the main point of discussion. Okay, so that's why we are using this type of analysis, that is a fully coupled flow deformation analysis. Okay, and this analysis is taken care the two different aspects is that like it considers the flow through the saturated zone and the flow through the unsaturated zone. So the good thing, this fully coupled flow deformation analysis in the Plaxis considers both the phenomena, that is the flow through the saturated zone and the flow through the unsaturated zone, which is the real life conditions. So in some cases your soil is fully saturated, in some cases it's partially saturated, or in some cases it's a fully dry. So to consider all these aspects, Plaxis consider this thing inside the analysis. Okay, it account the unsaturated behavior section in the unsaturated zone above the phreatic load is phreatic level is also taken care, and that's why ignore section option is not available in the case of fully coupled flow deformation analysis. Okay, so this fully coupled flow deformation analysis is, of course, it's a time dependent analysis. You need to give how much time that you're considering in your analysis. Okay, for example, the rainfall is occurring for 1 hour also, it occurring for the 2 hour also, 24 hour also, 124, whatever. Okay, so we need to give the some time frame for how long you're considering this flow coupled flow deformation analysis, for 1 hour, 1 minute, 2 hour, whatever time, but that time you need to give. Okay, so it's basically this fully coupled flow deformation analysis, that time dependent analysis. And of course, along with this, you need to give the rainfall intensity data. Okay, now I'm coming to that point only. So again, in the Plaxis, there are two ways to simulate to model the rainfall inside the Plaxis. The method one, in that you simply need to give the this Q value, or I can say the infiltration value, in terms of like a meter per day or per hour, or whatever the data that you have, the rainfall intensity data, basically that data you need to give it over here. And along with that, you need to give the two additional parameters like the psi minimum and the psi max. So what is the psi minimum and psi max? So if you come to this side, this picture, psi max, if you see, it is somewhat above the it is somewhat above my ground surface. Okay, so this orange is my ground surface, and psi max I'm considering somewhat above, like I'm considering the 0.1 meter. Okay, and if you see, the psi minimum is lying somewhere below the ground level at some here in this case I'm considering the point -1 meter. Okay, so my ground level I'm considering it is 0 meter at the 0 level, and the psi minimum is of course in the negative direction, so it is -1 meter, and the psi max is a positive 0.1 meter. Okay, so what is the psi max, psi minimum? So in Plaxis or in this software, we need to assign some boundary conditions for the rainfall. What is that boundary condition? So psi max, here I'm giving as a 0.1 meter. So when the rainfall is occurring, okay, then some portion of the soil, this rainfall or this water is start infiltrating inside the soil, and after the saturation is happening, then what happened? Then runoff is occurring. Okay, so here we are suggesting that when the water accumulation goes beyond this 0.1 meter, then that accumulated rainwater simply comes as a runoff. Okay, that is the meaning of this psi max. Okay, so whatever the rain excess rain fall occur above the 0.1 meter, okay, that simply comes as a runoff. Okay, and the psi minimum is representing that, of course, then when this rain comes inside the soil, get infiltrated inside the soil, then when it reaches to -1 meter, so whatever the excess quantity of rainfall is there, that simply get evaporated. So that is the meaning of this psi minimum and the psi max. So that again depends upon you. As per your field condition, you can change the psi max and the psi minimum value. Okay, and at the bottom, if you can see, the time dependency is the constant, but we have the flexibility. You can choose in between the constant and the time dependent flow function. So like for example, what is the meaning of this time dependency? I'm just explaining you. Here I'm mentioning, for example, the rainfall intensity, the Q value, as 5 mm per hour. Okay, and I'm assigning time duration for the calculation as a 24 hour. Okay, so it means that, and if I keeping the time dependency as a constant for this condition, so it means that this rainfall intensity 5 mm per hour is constant throughout this 24-hour duration. Okay, but in reality, there may be scenario that in this 24-hour, for the initial 1 hour, the rainfall intensity is like 2 mm per hour, and again it get drops in the next hour. Again in the next hour, it increases to 10 mm per hour. Again it drops. So there is some this intensity get reduced, okay, or it get increased, it get decreased with the time, okay. In the Plaxis, you can have that flexibility, the time dependent. You can choose in the time dependency as a time dependent, and you need to assign the flow function. Okay, it means you need to give the value like flow intensity versus time. That data you need to give in the Excel sheet or in the notepad kind of a format.
Raghu sir.
Dear participants, please wait for a while. We are contacting the resource.
Sure, sir. Sure.
Hello, hello.
Yeah, audible, sir.
Rohan.
Now I'm audible.
Yeah, Rohan.
Sorry, my data get lost. Sorry, and now I connected through another network. Can you just let somebody please let me know where I missed or where I'm get disconnected so that I can resume from that slide. Just a second. So are you aware? I have already explained this modeling of rainfall. So is there any need to explain this slide again? Can someone please unmute and let me know?
Uh, yes, we have understood, sir. You can continue.
Okay, thank you. Okay, so the last part is the slope stability assessment. Okay, till now we understood the input parameter that required the Van Gogh function, the flow through saturated zone, unsaturated zone, fully coupled flow deformation analysis, then how to model the rainfall inside the Plaxis, the input parameter that required psi minimum, psi max role, the time dependency of the rainfall intensity, and all those things. But the problem still remain how to get the factor of safety values, okay, with rainfall intensity, with change in rainfall. Of course, when the rainfall is there, with time, with rainfall, the factor of safety start reducing for our slopes. Okay, how the Plaxis or this finite element tool is taking care or determining the slope stability or this factor of safety. Okay, so in the finite element we are using this method phi psi reduction. In some of the book we call in they have mentioned this method as a strength reduction method. Okay, or in short the SRM. Okay, so what we are doing in this method, how we are determining the factor of safety in the finite element method in the Plaxis software. So this is my slope, which is just imagine that this is made up with some soil, which having the cohesion value as a 25 kPa. Okay, so what we are doing, we are start reducing the strength of the soil, and along with that we are introducing one force in the geometry such that at some time, at some load increment and some with some reduced C value, the failure get occur like in this fashion. Okay, so we keep on increasing this load to make the slow failure, and at the same time we keep reducing this C value. Okay, we are increasing the load and we are keep on reducing the C value, the shear strength of the soil. Okay, at one point, at one load and what at one reduced C value, there is we observe that the failure is occur like this fashion. Okay, and that reduced C value we use as to get the to calculate the factor of safety. So factor of safety in this case is simply equals to the available soil strength, the actual, the natural, the original soil strength, which in our case is, for example, 25 kPa. And we found that when the C value is reduced to, for example, 13 kPa, then the failure is occur. Okay, so the reduced say in your case is 13. So just take the ratio 25 by 13. So that is the factor of safety in this scenario. So this is the equation we are using in the finite element tool, or the fact in this in the Plaxis tool. Okay, so this can be C. Okay, or in some cases that can be the angle of internal friction. Okay, and in the Plaxis, that factor of safety is represented by this symbol summation of MSF. So this summation of MSF is nothing but the factor of safety in short. Okay. Okay, and another interesting tool and thing is I need to highlight over here. This strength reduction method or this 5-side reduction method is only applicable when you're modeling your soil or the rock as a Moore-Coulomb failure criterion. Okay, there are many different constitutive laws are there, like jointed rock model, Hook-Brown material model, Moore-Coulomb, hardening soil. There are many material models, many constitutive material models are there in the finite element, but this strength reduction, 5-side reduction method is only applicable when you are modeling your soil and rock as a Moore-Coulomb failure criterion only. Okay, I'm skipping this part. I'll cover during the demonstration. Okay, so I'm just summarizing the advantages that we get with the finite element. So the first is the no assumption is need to be made, like the shape of the failure or the location of the failure surface. If you remember, if you recall, in the limit equilibrium approach, like there are different limit equilibrium approach, like ordinary method of slices, Bishop method, Felonius method. Many methods are there, and in all those methods, there are assumptions like the failure surface is circular in nature, linear in nature. But in the finite element approach, such assumption is not there. Okay, and the failure occurs naturally through the zone within the soil massage at which the shear strength is unable to sustain the applied shear loaded shear stress. So the failure pattern can be a random shape, it can be a circular shape, it can be a translation, any shape. Just only thing is that passing through the soil of where the shear strength of the soil is the lower than the applied shear stresses. Okay, another assumption, another advantage is that there is no concept of slices in the finite element approach, so there is no need for the assumptions about the slice slide forces. So that is another advantages. FM preserve the global equilibrium until failure is reached. If realistic soil compressibility data is available with you, you can able to get the extra output like the deformation at the working stress level, and FPM is able to monitor the progressive failure up to an inclining, including the overall shear failure. So these are the few advantages are there in the finite element approach. But of course, some limitations are also there. Of course, no method is perfect. So let's try to see what limitations are there in the case of finite element method. So finite element use the 5-side reduction method. Okay, 5-side reduction method, or we also call that method as the strength reduction method. Okay, at some scenario this finite element tool is lacking. Okay, so what those scenario, okay, that I'll try to explain with this figure. Okay, so just first of all concentrate on this side. This is an earthen dam. Okay, so the upstream, sorry. Uh, so the water level is somewhat like this on the upstream face. This is my upstream side, and this is my downstream side. Please allow me, I'm just drawing this with my mouse, so my handwriting is not that much good. Okay, so of course, when the fluctuation is occurring in the upstream side, fluctuation in the, of course, water level, so that makes this upstream phase in the critical condition, critical scenario, and because of that, what happens? This portion, this upstream slopes in the danger situation, and same thing is showing in the output of the Plaxis finite element tool. Okay, you can see this is the failure zone like this. Okay, so of course the failure is occurring in the upstream side. This is very obvious because the fluctuation of water level is occurring in the upstream side, and this is the earthen dam, so there is chance the water starts seeping through this earthen dam. Okay, but if my interest is to see this the factor of safety for this slope, and even if you notice the slope angle is quite higher for the upstream compared to the downstream slope. So of course with that also this portion is going to be failed compared to the downstream slope. But if my interest is to see the factor of safety for the downstream slope, so in that scenario, this Plaxis will not help you. Okay, why? Because this finite element tool gives you only the global factor of safety or the global equilibrium conditions. Okay, same scenario now coming toward this side, second side. Okay, you can see this is my water level. Okay, this is the upstream side, and this is the downstream side. Okay, now this arrow is actually nothing but indicating the water pressure acting on the this upstream slopes. Uh, After doing the analysis, Plaxis is showing that this is the lowest factor of safety or the critical slip surface. Okay, but if my interest is to see the factor of safety for this berm portion or to see the factor of safety for the upstream phase, then Plaxis will not help you. Okay, because Plaxis, as I already mentioned, Plaxis give you the lowest factor of safety portion only, or I can say the global factor of safety only. Okay, so in this geometry, in this overall geometry, this is the critical position where the factor of safety is lower than this low portion and this low portion. So Plaxis gives only this factor of safety for this scenario. It will not give the factor of safety for this portion and the upstream slope portion. So in this case, my suggestion is you can go with the limit equilibrium approach where you have a flexibility. You can choose in between, and you can have the flexibility where you wanted to find out the factor of safety. You can choose that geometry and you can get the factor of safety for your desired location. So this is the limitation of the finite element tool, or I can say the factor of safety in the case of Plaxis. Okay, now I'll go into the in the software Plaxis. Just a second. Okay. Can somebody please let me know my screen is visible and I am audible perfectly?
Yes, sir.
Yeah, thank you. Because I'm just confirming myself because I'm connecting through hotspot. So maybe sometimes I may get disconnected. Okay, so it's good that I am audible to everyone. Okay, so this is the typical graphical user interface for the Plaxis 2D software. There are 5 different steps which we need to follow. First phase is the soil phase, where we need to model the soil or the rock material, whatever we have in our borehole or in our bore log. In the structure tab, you can model the structures like pile, raft, soil nails, geosynthetic structures, buildings, whatever, or loads, line loads, prescribed displacement, whatever the structural thing that you need to do, that you can do in the second phase. Third phase is the mesh creation. Of course, this is a finite element tool, so you need to create a mesh. Again, we have a lot of flexibility in the mesh generation that I will show in the upcoming time. And second last thing is the flow condition, where you can adjust the water table in your geometry as per the bore log report. And the last one is the stage wise construction analysis. Okay, so I have already created this geometry. Okay, I'm not going into the detail how I have created the geometry, but if you wanted to create this kind of a geometry, there are few options are available. I'll quickly show you that options. Either you can use you can just go into the structure. There is one option line element. In that you can see the create a line element is there. With that you can model this kind of a geometry. That is the first option. Second option is that create a soil polygon. You can use this soil polygon options, but make sure that you have the coordinate for x and y coordinate for your polygon, and with that you can able to create the geometry. And the third option is that to create this kind of a geometry is there is an option import geometry at the bottom. You can see this option import geometry is there, and this Plaxis supports different file like .dx. If you have the AutoCAD file with you for your geometry for your slope, if you have the cross section with you, that AutoCAD file, that .dx file, you can simply import that, and with that you can reduce the time for the creating the geometry. Plaxis also support the other format like .csv, .go, .sti, and many other. So that directly you can import, and you just need to assign the soil material to your geometry. So all these three options are available with you. You can go with the create a line option, create a soil polygon option, or you can simply import the geometry inside the Plaxis. Okay, now I'm again coming back to the soil material. And in that I'll show you the two soil materials which I have considered in this simple problem. I'm keeping my problem a little simpler. I'm just taking the two soils and this much of angle. Okay, I'll quickly show you the properties that I have taken for one of the soil. I'm just giving the name as the upper layer and the lower layer. I'll quickly show you the for upper layer what the parameters that we need in the analysis. So identification purpose, I'm just giving the name as an upper layer. In your case, you can give the name as a clay, silt, sand, gravel, any name. Okay, it is just for the identification. You can just give the name as a layer one also. This is just for the identification purpose. And in the soil model, we need to select the Moore column only very, because if you remember, here we are doing the factor of safety calculation. We are using the 5-side reduction method. Here we are using the strength reduction method. And this 5-side reduction method, this strength reduction method is applicable only for the Moore column material models only. Okay, but sometimes for to model the rock in the Plaxis tool, we recommend you to go with the hook brown material models. Okay, or you can go with the jointed rock models. Okay, but when you're modeling your rock material with the hook brown or the jointed rock model, in that case, this 5-side reduction method or the strength reduction method to find out the factor of safety is not at all applicable. So for that, those two material models, different techniques are there, different methods are there. For that, I'll suggest you to go into the Plaxis reference manual. In that, it is clearly mentioned which method that they are adopting when you're modeling your rock with the hook brown material model. Okay, so right now we are going with the simple Moore column material model. Okay, I'm keeping the drainage type as a drain one only. So also you can change the color as per your wish from this one. And the unit weight you need to give as unsaturated and saturated for your soil material. I'm just considering 18 and 19 kilonewton per meter cube. I'm just keeping this void ratio and the relay damping factor as of now, because this relay damping factor is required when you're doing some dynamic kind of analysis. Right now, my point of interest is the factor of safety calculation. So I'm just simply skipping this. Now in the mechanical tab, the input parameters is like the modulus of elasticity you need to give. So E dash reference is nothing but the modulus of elasticity in terms of the kPa, Newton per meter cube, meter square. Right now I'm assuming 25,000 kPa as a E value for my upper layer. Poisson's ratio, that is the new, is 0.23 that I have assumed. And the parameter that you are seeing in the green color, that it automatically get calculated, like the shear modulus, iodometric modulus value, it get automatically calculated, because there is a correlation between the shear modulus, elastic modulus, and the Poisson's ratio, and with that these values get calculated automatically. After stiffness parameters, the very important input parameter that we need to give the strength parameters, like the shear strength parameter. So you can see the C dash reference, that is the effective cohesion, you need to give as a in terms of kpm. Right now I'm assuming as a 8 kilonewton per meter square for my soil, or 8 kpm. 5 value effective 5 dash, sorry, effective angle of internal friction, I'm assuming the 25 degree. So these are the few input parameters are required, important in the factor of safety calculation. Now coming toward the groundwater tab, here we are using this very famous Van Gogh function as a SWCC fitting method, that is a soil water characteristics curve. Why it is required? To model the flow through my soil through the unsaturated zone. So for that, this is very important. This SWCC curve, you can see those curve in this case. Okay, so I'm considering my upper layer soil as a silt one. Okay, so you can toggle in between. There are different options is given over here. So you can toggle in between and you can choose as per your condition. Also, you can adjust the particle size distribution for your soil. How much percentage is there for the 2 micron? How much percentage for 2 micron to 50 micron? Okay, so that percentage you can adjust over here. And for flow permeability value, you can use the by default permeability value, the kx and ky meter per hour, and you can also put the values as per your laboratory data. If you have the laboratory data with you, permeability data for your soil, you can just put that values over here. Just untick this box and put the values for your soil. Okay, so these are the few things are required. I'm just keeping this thermal and interface values because they are not having that much of importance for this factor of safety problem. Okay, similarly, I have also modeled the lower layer. Okay, okay. So the soil property is now assigned to both the layers. The geometry is now also created. Okay, and in the third phase, the mesh create, you need to create. So if you go into the mesh mode, there is one option, generate mesh. Okay, and in that you get the flexibility. You can choose in between very coarse to very fine mesh. So right now for this problem, I'm keeping the coarseness as a mesh, medium mesh option. Okay, but it is totally depends upon the practitioners, or it is totally depends upon you which mesh size you want. So of course, when you go with the very coarse, the answer is quite approximate in nature, and when you go with the very fine mesh, you are more closer toward the real life scenario. But of course, when you are choosing the very fine mesh, the element size, element numbers are more, and the more computation times are required. Very obvious thing. Okay, and then in the flow condition, the second last step, you can see by default I am keeping the water level somewhere here. Okay, and that is this, which is the actual condition. But if you wanted to model the water somewhere here, you can use this option, create a water level, and you can mark the water level simply at any location as per your borehole data or the bore log report. Okay, so right now I'm keeping the water level at 2 meters from the bottom side. Okay, and now the stage construction, the different phases I have simulated over here. So very first is the initial phase. This is the initial natural condition of the slopes. Okay, this is the geometry, 2 layers of soil, and the water level is somewhere here. Okay, and after that I have added one phase, which is the factor of safety phase. Okay, I'll just quickly show you the in detail what is this initial phase and what is this factor of safety phase. Okay, so in the initial phase, I have the calculation type that I have used is the gravity loading. Okay, in the drop-down menu, you can see there are different calculation types are there for the initial phase, for the self, or I can say the very begin natural condition state. There is a K-naught procedure, field stress, and the gravity loading and the flow only. Okay, so which we need to adopt, that is a question. So this is the initial phase, and the geometry, if you see, there is a slopy geometry. Okay, and the importance of this initial phase is to find out the initial stresses which get generated because of the self weight of the soil. Okay, so of course that deformation, stress, strain we need to calculate prior to the rainfall simulation or the different phases of construction. So in the initial phase, I am considering the gravity loading because the geometry is not at all horizontal. Okay, but if in your case, if the geometry is completely horizontal, simply ground level is there and it's a horizontal in nature, soil stratigraphy is also horizontal in nature. In that case, I recommend you to go with the K-naught procedure to find out the initial stresses in your soil. Okay, so the information or the meaning of this, all the calculation methods are given over here. You can just read and select as per the field condition. Okay, after that I have added, after initial phase, after calculating the initial stresses, I have added one phase, that is the factor of safety. Okay, so what I did in the second phase of analysis, I just wanted to see how much factor of safety is there for the initial condition. for that bottom water level, for the actual geometry, what is the factor of safety? How much factor of safety is there? Prior to the rainfall, how much factor of safety is there? That I wanted to calculate. So that's why just after the initial phase, I have added, by just uh, clicking on this plus button, I have added this factor of safety phase. And if in the calculation type, if you just see for the factor of safety right now in the factor of safety phase, in the calculation, you can see there are different options are there: plastic, consolidation, safety, dynamic, fully coupled flow deformation, dynamic with consolidation. So Plaxis handle these different types of analysis. Plastic analysis, when you wanted to see the deformation, stresses and strain, in that case, you can go with the plastic. If you wanted to do the time-dependent consolidation analysis, you can just go with the consolidation analysis. When you wanted to see the factor of safety for your geometry, then go with the safety calculations. When you wanted to perform some earthquakes, some dynamic loading you need to apply, you can go with the dynamic loading, dynamic type of analysis. And when you wanted to perform fully coupled flow deformation, that we will see in the next phase, means we wanted to see the flow and also the deformation because of that flow, that we will see in the next. But right now, in the second phase, my interest is to see the factor of safety in the real condition, the natural condition. Okay, so that's why I prefer the safety as a calculation type in this. And after that, if you see in this tree diagram, I have consider this 24-hour rainfall as a phase. Okay, so this identification purpose, I am mentioning the 24-hour rainfall. You can give any name, 2-hour rainfall, 1 hour, whatever, as per your, it is just for the recognition purpose or for the identification purpose. It is editable. You can change the name of that phase. Okay, so I'm giving the name as a 24-hour rainfall. Okay, and it start from the initial phase. Okay, and if you see the calculation type that I have chosen is the fully coupled flow deformation analysis. Okay, because in this phase I wanted to simulate the 24-hour rainfall. Okay, so that's why I chosen this phase, fully coupled. I chosen this calculation type as a fully coupled flow deformation. So in this phase, Plaxis consider the flow calculation also, and because of that flows, how much deformation is occurring, that also Plaxis taken care of. Plaxis also calculate that one. And in the this side, at the bottom side, if you see the time interval, I'm keeping the time interval as a 24-hour. Okay, so you can keep that interval as a in minute also, but at the beginning itself, when you're selecting the properties for your geometry, just make sure that you are selecting the unit for your time as a minute or the second. So it is again depends upon you. You have that flexibility. So I'm keeping the time interval as a 24-hour. Okay, and after simulating this phase, I have added the factor of safety calculation after 24-hour rainfall. Okay, so now I need to see how much factor of safety get reduced when the 24-hour rainfall occur. Okay, so you can see after 24-hour rainfall, immediately I added one more phase, and in that phase I consider the calculation type as a safety. Okay, now in your mind there may be question where we consider the rainfall intensity. Okay, so again I'll come back to that 24-hour rainfall. Okay, and if you see in the 24-hour rainfall, if I just expand this boundary condition in the model explorer, in the model condition you can see there is one tab, precipitation. Okay, so just expand that one, and you can see I have given the rainfall intensity as a 5 into the 10 to the power of -3 meter per hour. So in short, it is the 5 mm per hour as a rainfall intensity I have given. So you can give this rainfall intensity as per your wish. And this 5 mm per hour and the psi minimum and psi max, I'm keeping psi minimum as a -1 meter and the psi max as a 0.1 meter. And I'm keeping this 5 mm rainfall intensity for a 24-hour duration. And that 24 time I'm managing in this phase. Okay. Similarly, I added one more phase, and that the name of that phase I'm keeping as a 120-hour rainfall. Here I'm keeping the time duration as a 120 hour, and the rainfall intensity I'm keeping same 5 mm, just to see to simulate the very worst scenario. Means for 120 hour duration, a very constant rainfall intensity, that is 5 mm per hour for a very long duration, how much factor of safety get reduced. So for that, again, after 124-hour duration rainfall intensity, I have added one more phase, that is a factor of safety after 124-hour rainfall. Okay, now these phases are already run. I just wanted to reduce the time for the calculation, because if I start calculating in front of you, it takes a lot of time, and then we are not able to uh, uh, discuss the output. Okay, so this green tick, it means these phases are calculated successfully. When you're not calculated at the beginning, it's showing in the blue fashion like this. Okay, when the calculations get done successfully, then they turn into the green in color, in the green arrow color. Okay, now let's see the output. Right now I'm in the second phase, that is the factor of safety phase in the initial condition. Now I'm going into the output for this one. Now I'll quickly summarize this in next 2-3 minutes, and then we'll go for the Q&A session. It asking me the permission. Just a second. I hope I'm audible to everyone. Can someone please unmute and let me know?
Yes, sir.
Yeah. Thank you for the confirmation. Hmm. Yeah, finally it opened. Now we are in the output view. I don't know why it gets slower down. Anyways, okay. Now we are in the now output window of Plaxis 2D software. And we are in the factor. You can see whatever the phases that we have seen, all those phases you can see in this drop down menu. Initial phase, the factor of safety phase just after the initial calculation, then the 24-hour rainfall phase, factor of safety after that 24-hour rainfall, 120, all those phases you can see, and you can toggle in between. Now I wanted to see the factor of safety for the initial condition. Okay, and I wanted to see the deformation, how much. Okay, so you can see this is the failure zone for the natural condition for my slope, okay, without any rainfall. And you can see the dark blue line is actually indicating the water level, the natural water level. And the interest is to see the factor of safety. So just go to the project and go into the calculation information, and just go on this side, the summation of MSF. If you remember in the presentation we discussed, the summation of MSF is nothing but the factor of safety value. So the factor of safety value for the natural condition is the 1.464. Okay. Now you you see the deformation is 261 meter. Okay, in the factor of safety phase, but this deformation is not having any physical meaning. Okay, uh, if you remember, I during the strength reduction method I explained this to make the slow this geometry fail. What this Plaxis or what this phi-psi reduction or what this strength reduction method is doing, it introducing one unbalanced force in the geometry, and it tried to make the slope fail. Okay, and because of that, this unrealistic deformation is occurring. This is not having any physical meaning with the actual deformation. Of course, 200-meter deformation is not at all acceptable. Deformation maybe in millimeter, maybe 5 meter, 10 meter, like that, but not, of course, not in hundreds of meter, kilo, in terms of the kilometer. Okay, this is not a realistic value when you are checking the factor of safety phase in particular. Okay, it is not having any physical meaning. Okay, now I am going in the 24-hour rainfall duration. Okay. Okay, so you can see because of the rainfall, this is the I'll show you the total displacement. Okay, so the deformation is because of the rainfall. 24-hour rainfall is 1.72 mm. Okay, and if I wanted to show you the uh, saturation, you can the active pore water pressure which is there, and I wanted to show you the saturation. Yeah. Okay. So you can see the saturation because of the 24-hour rainfall. The red zone indicating the degree of saturation. So 100% saturation represent the red color, and you can see this much of portion, the top portion and the bottom side. Of course, the rainfall, the water start accumulating in the downward direction, and this much is the degree of saturation. This much of portion get saturated. Okay. Now the interest is to see the factor of safety after 24-hour rainfall. For that, I'll go into the deformation, total displacement. So this is the failure zone, and the point is to see the factor of safety for this after 24-hour rainfall. You can see for after 24-hour rainfall with 5 mm intensity, the factor of safety get reduced to 1.44. For the natural condition, it was 1.46. Now it drops to the 1.44. Not big reduction because the intensity is also very low. It is 5 mm per hour. Now let's see the 124-hour rainfall and the saturation of water. Okay, now you can see the big portion of my soil is now saturated because of the huge rainfall intensity duration, that is a 124-hour duration with constant rain intensity, that is 5 mm per hour. Okay, and now need to see the factor of safety after 120-hour duration. Go to the project and the calculation information. The factor of safety is drastically reduced now. It is just 1.09. Okay, because the 24-hour to 124-hour, big duration. I also wanted to show you one animation which I have taken from this project only. You just concentrate on the time, okay? With the time, how the saturation get changes inside the geometry. So this is showing the time versus saturation animation. Okay, the red color indicating the saturation, 100% saturation, and in this bracket you can able to see the time. Okay, I'm just starting this video. Okay, you can see the time is changing 3 hour, and now slowly the rainfall is occurring, and now you can see this portion is now start saturating. Of course, the bottom portion at the beginning now, because the water start accumulating in the down direction, very obvious in nature. Then now time is now 10 hour. Most of the portion at the bottom is now saturated. Bottom water level is now also increasing. Okay, now 14 hour. Now I'm simply taking this video in the moving forward. 38-hour duration, big portion of the soil layer is now also saturated. I'm now again going further with 61-hour. You can see this all the top portion is now saturated. Again, go little further, 100-hour. You can see now big portion, and the bottom portion is also now saturated. And now at near about 120-hour, you can see this much of portion is now get saturated. So this kind of animation you can also able to generate with the software like Praxis. Also, you can able to draw the load versus deformation curve, factor of safety curve, and many other things. So that's all from mine. I wanted to keep more time for the Q&A session. I hope there are many questions are there in the participants' mind. Please, I'm ready to answer your. Sorry for that. I'm going in very fast space to cover all these things. I'm extremely sorry for that.
Thank you very much, Rohan. Uh, we welcome all the participants for the question and answer session. You can text your question in the chat box, or else you can unmute yourself and ask. There is a question from Nagarajan, Rohan.
Yeah.
How can early warning systems based on rainfall forecasts and real-time slope monitoring help prevent or mitigate rainfall-induced slope failures?
Okay, I'm just again reading his question.
Yeah.
How can early warning systems? Okay, so early warning systems means if he can elaborate me in detail based on rainfall forecast and the real-time slope monitoring helps to prevent the mitigate. Okay, so I wanted to give the answer in a little different way from the software point of view. So for example, you have the tool like this Plaxis or any other geotechnical software tool like the GeoStudio and many other. And if you have the rainfall intensity with you for that location, also you should have the, of course, the geometry data for your your slopes. You should have the soil data or the rock data for your region, and just make sure that you have the rainfall. Very worst scenario means whatever the maximum rainfall occur in that region, just take that data and you try to simulate that thing in the Plaxis like a tool, and you can predict if that rainfall, that very high intensity rainfall occur for whatever so and so duration, then how much factor of safety get reduced, or how much failure chances are there, that you can predict early in advance with the software. That you can do. But if you're asking from the some instrument point of view, then frankly speaking, I'm not aware about that one. Yeah. So there is one more question: how can impact of climate change, including the rainfall frequency and intensity, be incorporated in the slope? Yeah. So as I mentioned earlier, in the Plaxis, you have the flexibility to model the different rainfall intensity. You can toggle. You can check for the different time duration. Also, you can able to simulate the rainfall intensity with different time frame. Okay, you can change the rainfall intensity with the different time interval. So you can consider that rainfall effect, the different intensity, different frequency with different time. Recent landslide failure at Kerala, any information of its failure? Yeah, the main reason was the of course the rainfall only, but there are few other reasons, like people they constructed some structures nearby that bottom portion of the that slopes, that also one of the reason. And rainfall, the huge rainfall intensity for a shorter duration is the main prominent thing which behind that tragedy, behind that Kerala landslide. Thank you very much. How can you, the remote sensing technology, satellite imagery, LIDAR, UAV, improve the detection on monitoring slopes, vulnerable failure after heavy rainfall? Sorry, frankly speaking, this is out of my scope. I never did this LIDAR and the satellite imagery technique. What role does soil permeability play in the assessment of rainfall-induced slope failures? Yeah, very important and quite relevant for me. To me is, yeah, of course, the soil permeability plays a very important role. Uh, in this Plaxis, or in this finite element tool, we are considering the calculation type as a fully coupled for deformation analysis. Okay, so this flow which we are simulating inside the software, it is totally depends upon the permeability value through a saturated soil, which I guess I already covered during the presentation. Okay, and the second thing, the soil water retention curve or the soil water characteristics curve, that is another important factor for the uh, unsaturated soils, okay, or the partially saturated soil, to model the flow through the soil. So this is very really important, permeability and the soil water retention curve or the soil water curve, without which we can't model the flow through the soil. This is really important. Apart from the rainfall, are there any other parameters for the slope failure? Yeah, there are many, not just the rainfall intensity, not just the duration, not just the permeability or the soil properties, the sloping geometries, sometimes the loading conditions, which I haven't considered in this simple problem. Some load, suppose some building loads is there at the top of your sloping geometry, or some excavation we have did at the bottom of the slope, at the top of the slope, that can also be one of the reasons. So there are many reasons are there which make the slope failure. I guess I covered this. What role does soil permeability? Many people, they are asking for the feedback link. Thank you. Thank you very much. Thank you.
It seems no question from the no further question from the audience, Rohan.
Right, right, right.
Thank you very much We are very happy with your time, and we hope that all our audience are happy with your presentation. Really, it deepened our understandings on this landsliding and Plaxis software. Uh, Now I would like to invite Professor Shashidhar to talk on it.
Yeah, Dr. Rohan, it was a very good lecture. Like the analysis through FEM. I mean, generally we are not exposed to that area. So you beautifully, I mean, you have explained in detail how to do and all. Thank you very much for sparing your valuable time. In fact, like because this geotechnical softwares were not much exposed.
Right.
Generally, structure side, most of the civil engineers are doing, but the geotech side, very few people know about the tower. I mean, the softwares. But after this lecture, I think they will have some idea how to use this and all. Those who are interested, they can do it. Once again,
Sure,
thank you
sure.
very much. I heard that you are very busy. You didn't get time. Even then, you have dedicated some time to us, and thank you, thank you. You're working for a very big company, Bentley. Even then, you have given time and came forward to give a lecture for this online FDP from JNTU side and from personally. I'm very much thankful to you, Doctor. Okay, thank you.
Yeah.
See you soon. Huh? Yeah, please.
Thank you, sir. Thank you for inviting me. Thank you, Raghu, sir. Thank you, all the
Thank you, sir.
participants. Yeah.
Thank you, sir.
Thank you. Bye.
Bye.
Raghu, sir, shall I leave?
Yeah, Rohan. Thank you very much.
Yeah. Thank you, sir. Thank you very much.
Raghu,
Yes,
yeah, first valedictory అయిపోయినాక we'll go for the examination.
yes, sir.
అజిత మేడం వచ్చినారా ఒక్కసారి యోగిని అడుగు.
Uh,
రైట్ రైట్ మా ఓకే. Yes, my dear, shall we start the valedictory function, Raghu? Bus lever.
yes, sir. You can
యోగి,
proceed.
Sir, yes, sir.
యోగి ఆ ఫొటోస్ పెడతావు నేను ఇందాక పెట్టినవి. యోగి,
Sir, 1 minute, sir. Share this.
yeah. So, my dear faculty members, I once again welcome you all to this online 6-day FTP on emerging trends in civil engineering department for disaster management. Uh, so actually, it was a hectic schedule. It started on 23rd and it's going to end this day. Hello. Yeah, due to the busy schedules, our Honorable Vice Chancellor sir is not attending. Only our HOD madam is attending. Yeah. Uh, Sorry, like actually I'm in a traveling, so that's a little bit disturbance. My dear friends, before going for the lecture, I just want to show you a photo. Uh, Actually, I'm a part, I went to Sikkim recently. I've seen this dam. This dam is a Chungtang Dam of Sikkim Urja Limited, 12,000 megawatts. It is
Voice breaking, sir.
on October 4th, 2023. There was a flash floods. Without opening the gates, the water entered into the gates and dam was collapsed, and that is the main hydropower station which gives electricity to the entire state of Sikkim, as well as it is going to the Bhutan also. So completely collapsed, and now it is in such a bad situation, it cannot be reconstructed. Now this picture shows the bad position of the dam. So, my dear friends, what I mean to say is like, we don't know how the disaster is going to come. It is one such example which I have seen recently. It's a heart burning, like very sad. Nearly 100 members have expired, it seems, from this scene. And that's what, like, disaster means it's a natural disaster. We don't know when it's going to come, how it's going to happen. Role of civil engineers will be a major in whatever may be the disaster happening in the nature. My dear participants, so I thank, first of all, I like to thank our university administration, Professor H. Sudarshan Rao Garu, in charge Vice Chancellor, for encouraging us to conduct this online FDP. He came for the inaugural session, and our principal is the person who forcefully insisted us to apply for this seminar. I mean FDP. Sorry, and my HOD, and she is the one who has given permission for applying this FDP, and the two persons who worked very hard behind this for the last 10 days. One is Dr. Raghu, associate professor from SRIT College, and my PhD scholar Yogi. These two members did a lot of work because I was out of station due to my personal schedules. They have taken all the pain in taking this program forward and successfully conducting this event. My dear participants, to say like almost 150 members, a consistent attendance is maintained right from 23rd to this day, which we can say that almost 80% of the registrations attended this FDP. Perfectly. Like with this, we can say that it is a successful online FDP program. And my dear participants, we have designed in such a way the program that all the civil engineering topics were covered right from the beginning. So we started with Dr. B. Kondravendan sir and Agnihotri, who have started their lectures on disaster management in civil engineering, and the second person on water resource management and flood management. Then one of the speaker is from Pawan Ananthaneni is from New Zealand. He has given lecture on disaster resilience, structural engineering. And next is P. Srinivasulu. He also spoke about earthquake resistant resilient structures. Then one wonderful lecture from Durga Jitendra. I have seen his lecture. Spoke on bridges against natural hazards. And Dr. N.V. Ramana, my good friend, spoke on disaster resilience civil engineering. Then Venkat Rao, he has given lecture on disaster assessment, monitoring, and predicting using remote sensing. And Jay Gopal, another practical person, he given lecture on case studies of rehabilitation of bridges and aqueducts. And Ashish Chandrapati, he has given application of geospatial technologies for disaster management. And Ramesh Naidu yesterday has given on drone technologies. And today we have three lectures. Dr. Kavita spoke on earthquake design of RCC, and Dr. Santosh spoke on wind analysis, and final lecture was Rohan Deshmukh on slope failure suspectability. So we can see that we have covered all water management, structures, bridges, case studies, GIS, GPS, and also drone technology. Like hope all the participants have gained the knowledge in the respective areas. Maybe we are not specialized in all the areas, but we have some idea. But this FDP is designed in such a way that it covers all the areas of disaster in civil engineering, please. And one more thing, I thank AACT for sanctioning this 6 days only online FTP. And I thank Professor V. Shankar Garu, a retired professor for alumni in charge, for giving the facility of this Google Meet and all. With this, I think anything like. Okay, so as per the ASC schedule, we have to give 13 lectures. So 13 are fulfilled, and 3 are from abroad. And you can see we involve more practical industry people rather than academicians, because academics somehow we can read, but industry orientation means that is very important, because they are practically working on the disasters. The same thing they explained in a beautiful way. So I hope all of you enjoyed these sessions, and if any mistakes from our side, you please excuse us. And this attendance is not an issue. We are going to sort it out, because there are almost 200 participants, and we have to do it individually. We are doing it by the end of the session. We are going to complete the attendance issues. Don't worry about it. And I wish you all the best for the examination. Maybe after this we are having examination. So, and one more thing, I have seen the participant registrations right from Manipur to Punjab, from South Kerala also. So almost all the participants are from the entire country, which I am very much thankful to you all. Yeah, one message came from Manipur faculty, which I was surprised. And there are some people from Ludhiana, Punjab also. So right like that, at Delhi and all. So I'm very happy, like because the faculty from the entire country has participated in this online FDP. I hope I have not. I'm not disappointed you. So we have given lectures in such a way that all the topics are covered, and all the speakers are eminent speakers who has interest in the subject. They only have taken the classes. With this, I think I'll stop my lecture. And participants, I wish you all the best, and in your future, and also for the examination. Thank you very much. Now we request our HOD madam, so kindly say a few words regarding this validatory function. Madam Ajita madam. Hello. Ajita madam. Yogi. Raghu.
Yes, sir. Yes, sir.
Ajita madam.
I'll call,
Yeah,
sir.
yeah,
I'll
please.
call, madam. Sir, one minute, sir. Madam will join.
Yeah.
Yeah.
Ma Ajita, please, ma. Now I request our HOD madam to address the gathering, please.
So actually, yeah. Sir, is my voice audible to you?
Yes, ma. Please go ahead, ma.
Yeah, yeah. So good evening, everybody. So it is a great moment and a great pride as we come to the conclusion of this faculty development program on the disaster management. On behalf of my heartfelt gratitude to all those who made this event a grand success. So the first and foremost, I would like my express my deepest thanks to our Vice Chancellor sir for his support and guidance, and also a special thanks to our principal for your support, sir. And also, I would like to extend my appreciation to all the resource persons who graciously shared their time, expertise, and wisdom with us. So the sessions which was conducted were both informative as well as thought-provoking. So and also I wish a great thanks and also a great congratulations to the organizers for their outstanding efforts. So from the initial planning to and also to the two smooth they have finally done a great Shashi sir as well as and Yogi and Raghu Babu. They have done a good job. Thank you very much, and also congratulations to all the organizers. Finally, a huge thank to the and also congratulations to all the participants. Facts and experiences, so that your it will shows it shows that your commitment for learning and also making this event a grand success. Thank you one and all.
Yeah. Thank you very much, madam, for your encouraging talk. So now I request Raghu to give vote of thanks, please. Raghu.
Am I audible?
Raghu.
Sir, am I audible?
Yeah. Please,
Yeah.
Raghu, go ahead.
Good evening, everyone. As we come to the conclusion of this 6 days online faculty development program sponsored by ATAL, it is my privilege to deliver the vote of thanks on behalf of JNTU Anantapur. First and foremost, I extend my heartfelt gratitude to our esteemed speakers for sharing their valuable insights and expertise and various uh, topics related to disaster management. Really, all the sessions have been truly enlightening and have left us with much to reflect upon and apply in our respective fields. I would like to thank uh, Vice Chancellor sir and Principal sir and Head of the Department of Civil Engineering for gracing the occasion with their presence and for their valuable contributions. A special note of thanks to our organizing team, coordinator Shashidhar sir, and supporting team Yogendra for their meticulous planning and seamless execution, ensuring the success of this event. Your dedication and hard work behind the scenes have been commendable, sir. To all the participants and attendees, thank you for your enthusiastic engagement and for making this gathering meaningful through your active involvement. Finally, once again, thank you all for being a part of this wonderful event. We look forward to more such enriching experiences in the future. Wishing you all a great future ahead. Thank you. Sir, are you there? Professor, are you there?
Raghu,
Yeah, sir. Can you hear me?
what about the exam, Raghu?
Yeah, sir. Exam will be started at 8:30, sir. Almost we have given attendance to 50% of candidates. We are working on
Okay.
it. We no need to bother about the exam.
About the attendance.
Yeah, about the attendance, it will be
Ah.
sorted soon. Already 50% of participants have got the attendance and they are writing the exam as well, sir.
Okay, okay.
I'm
So what
requesting
about
all
the
the
Sir, we didn't get, sir.
other persons?
Yeah, we are working on it, sir. No issue. After fixing the attendance, the portal will be open for them. They can give attendance later also.
Hello.
Exam when they have to write?
Hello.
Sir, examination link is not there.
Raghu.
Sir.
Hello. Sir, kindly update attendance, please, sir.
Yeah, we are working on it, sir. Please open your portal and check whether the tab is activated or not.
Hello,
Without
excuse me,
any
sir.
attendance, we
Sir,
are not
my
able to.
examination link has not come, sir.
Sir,
Sir,
I'm not able
please ensure
to
that you
submit
have.
the feedback also because the attendance is not submitted yet.
Hello?
And what to do, sir? We are having only 30 minutes to complete the exam.
No,
Yeah,
we'll extend it, not an issue. Please, wait. We'll sort
Hello?
out all the issues.
We need to
Raghu, sir.
ensure you are having the attendance of 80%. That matters a lot, ma'am.
Raghu, sir.
Sir,
The link is not come.
updated.
Examination link is not there.
Sir, if you have 80% attendance, then only it will be activated, sir.
I have attended all the programs, sir.
Dear participants, a small clarification from the coordinating team. Those who have joined with different email IDs other than what you registered in the site.
Raghu.
Your email. Sir, 1 minute, let me complete. I request the participants, those who have joined with different email IDs, it is been difficult for us to check whether it is been you or not. So it is been taking time. So kindly spare for some more time so that all the attendance will be updated. And the other
Sir, I attended with the same mail ID.
Sir,
but link is not there.
Sir, just wait, sir.
And one more thing, sir, you can keep exam timing for 24 hours as well, sir. No need to keep only half an hour. You can
Sure. We'll do it.
After updating the attendance, you can keep for the duration sometime. Thank you.
Okay.
Here is a suggestion, sir. Right now, most of the FDPs are going to be concluded today. The website will be down, sir. So we cannot access the properly the website, sir. That will be another challenge.
Hello, Raghu, sir.
Sir, what is the problem we are facing is we have to update the attendance one by one. There are almost all 250 registrations. So it is being taking so much of time as the site is down for us also to update the attendance. That is the problem. So kindly spare with us, sir. I request all the participants to kindly spare with us.
No, Shashidhar, sir. Shashidhar, sir.
Yes, sir, we are here. Please.
When the attendance is uploaded, only link will come, no?
Yeah, of course it will come, sir. No issue.
But
we are not sure when. Sir, Raghu, I have a doubt.
Sir.
When attendance is uploaded, then only link will come, no?
Yes, sir.
The link is not showing in my portal. I have attended all the sessions from day one.
Sir, you should be stay cool. We are working on it. We and me should work on ATAL portal itself. It is not working well. Please, I am requesting you.
So the problem is that when we will come to know, sir, that attendance has been uploaded or not, we cannot stick to the system for almost 4 hours continuously. Do you agree, sir?
Yogi.
Sir.
Can we extend that time?
That is what I am checking in the sites.
Yeah.
Yes, sir, definitely. Because we attended many FDPs, we can keep for the 24 hours as well. Once you complete the attendance updation, then you
Actually,
give the
sir,
signal. You
Sir,
give the
actually-
signal to the WhatsApp group. All attendance has been updated. So go for the exam. So that's
actually,
it.
sir, there is an option to dump the attendance as a whole, but it is not downloading in the portal. We are unable to download that template.
Maybe it's a technical issue. You can do it in later on also. But thing is, you just announce, keep the exam schedule for the 24 hours, not for half an hour.
Yeah,
Because
we are
everyone is worrying for that.
No, here the thing is, the link is also not there.
Now, once it is attendance is updated, means your link will be updated definitely, no doubt.
Oh, without attendance, the link will not be there.
No.
Sir, one doubt is there.
What about feedback, sir? Actually, many online FDPs are taking exam by Google
Yes,
Form, sir. Google
yes,
Form.
yes.
Yeah.
So why can't you take Google Form also, sir? You take
Yeah. If it won't work, we will send a Google Form and we will take the exam from there. Okay, no issue.
Yes, sir. Yes, sir. Thank
Problem
you.
is that, sir,
Thank you.
we don't know how to wait for you.
Sir, what about online feedback, sir?
Yeah. Once we entered your marks in the portal, then feedback link will be opened. No issues there. If it won't work, we will send a Google form and you can write exam there. Based on that, we will assign the marks and we will give the attendance. The problem will be resolved. No issue anywhere.
Okay, sir. Okay, sir.
You will
Thank you, sir.
update, give the Google form, sir.
Yeah. We are
Thank you,
working
sir.
on it.
Sir, this is Kiran, sir. Sir,
Yes,
in
sir.
my ATAL portal, it's showing absent, sir. It's been updated and it's like showing absent for all the sessions, sir.
Sir,
Exactly. For me, my case also, all sessions are showing absent.
Yeah, sir. Here we traced the attendance based on the Google meeting. Google meeting. We are strict on it.
So now can I be able to take tests, sir?
Yeah. If you attended for all the sessions
Okay.
and you are unable to give your exam, sure we will send a Google form to you and we will give marks on the Google based on the Google form and we will allow you to give the feedback and we will try to issue a certificate from AICTE.
Sure, sir. Sure, sir. Thank
So
you.
you are sending now Google form?
If it won't work, then only we will send Google form, sir. We will let you know by today itself.
Dr. Raghu, one more issue. My login, I logged in with lbce.edu. Instead of in, I logged in with on. But I think your GTP Naidu at lbce.edu.in is the original email. But I logged in with AICTE portal as edu.on. But previously, one more FDP I attended, I got the attendance, but whether my attendance is updated or not, I want to know.
Yeah, we will let you know. Actually, we will share all the attendance sheets in the WhatsApp group if possible.
Okay.
Okay. No issue, sir. We will let you know if you have attendance less than 80%. We will let you know.
Yeah, I attended all the 6 days, no issue. But
Okay, sir.
let me know what is my attendance
status.
When you will post the status.
We will let you know by today itself.
Okay. Thank you.
Thank you.
Sir, very good evening, sir.
Good evening, madam.
Sir, this is Ashwini, sir, Dr. Ashwini Balakumar from
Yes,
ATS
please, ma'am.
Village Engineering College, sir.
Yeah.